Siri_bot says Siri_bot has joined Cerebro Love.
What should I? Membership can support more than 2 modes. Only kernel mode and user mode are commonly used these days. In kernel mode, anything goes. Did I read this? Yeah. Pressure to start in kernel mode for executing a program. The kernel initiates the switch to user mode. Example of how processor modes manifest in a real architecture. 664. The current privilege level, CPL, will be read from a register called CS. Code segment. Oh, CS register. Specifically, the current privilege level is contained in 2 least significant bits of the CS register. Those 2 bits can store x86 tuples or possible rings. Ring 0 is kernel mode, and ring 3 is user mode. Rings 1 and 2 are designed for running drivers, but are only used by a handful of older niche operating systems. If the CPL bits are 1, 1, for example, the CPU is running in ring 3, user mode. What even is this call? Programs run in user mode because they can't be trusted with full access to the computer. User mode does its job, preventing access to most of the computer, but programs need to be able to access IOs, allocate memory, and interact with the operating system somehow. To do so, software running in user mode has to ask the operating system kernel for help. The OS can then implement its own security protections to prevent programs from doing anything malicious. If you've ever written code that interacts with the OS, you'll probably recognize functions like open, read, fork, and exit. Below, a couple of layers of abstraction. These functions all use system calls to ask the OS for help. A system call is a special procedure that lets a program start a transition from user space to kernel space, jumping from the program's code into OS code. User space to kernel space, control transfers are accomplished using a processor feature called software interrupts. During the boot process, the operating system stores a table called an interrupt vector table IVT 8664 calls this the interrupt descriptor table in RAM. And registers it with the CPU. The IVT maps interrupt numbers to handler code pointers. And usually programs can use an instruction like INT interrupt, which tells the processor to look up given interrupt number in the IVT, switch to kernel mode, and then jump the instruction pointer to the memory address stored in the IVT. And such forth. When this kernel code finishes, it uses an instruction like IRET. Okay, gotta go for a second.
Corrupt converter says assembly.
Okay, back. You just came in corrupt and said assembly. Nice. Right. What was I? When this kernel code finishes, it uses an instruction like IRET to tell the CPU to switch back to user mode and return the instruction pointer to where it was. Oh, when the interrupt was triggered. What does that stand for?
Corrupt converter says I gotta sleep earlier today because I need to wake up earlier.
Oh, that's okay. Don't worry about it. I streamed a lot later today than usual. Yeah. Oh yeah, interrupt return. Now you did tell me that in the past. Is this the same website that you linked me to? Huh. They also linked to it too. Yeah, after yours, because you're 3 hours ahead.
Converter says yes, started after my midnight.
I mean, that's why you're East Coast, East Coast, so yeah. Too bad for you. To return, tell the CPU to switch back to user mode, return the instruction pointer where it was when the interrupt was triggered. That's pretty cool. If you were curious, the interrupt ID used for system calls on Linux is 80. That's what we use in JDiddle. You can read a list of Linux system calls on Michael Karisk's online man page directory. We know man page now stands for manual.
Corrupt Converter says time to concoct a story for the people at MEPS.
Manual page directory. There's a whole list. Wrapper APIs abstracting away interrupts. Here's what we know so far about system calls. User mode programs can't access input, output, I think that's what that is, or memory directly. They have to ask the OS for help interacting with the outside world. Programs can delegate control to the OS with special machine code instructions like interrupt and interrupt return. Programs can't directly switch privilege levels. Software interrupts are safe because the processor has been pre-configured by the OS with where in the OS code to jump to. The interrupt vector table can only be configured from kernel mode. Programs need to pass data to the operating system when triggering a syscall. The OS needs to know which specific system call to execute alongside any data the syscall itself needs, for example, what file name to open. The mechanism for passing this data varies by operating system and architecture, but it's usually done by placing data in certain registers. This is what we do in assembly or on the stack before triggering the interrupt. The variance in how system calls are called across devices means it would be wildly impractical for programmers to implement system calls themselves for every program. This would also mean operating systems couldn't change their interrupt handling for fear of breaking every program that was written to use the old system. Oh yeah. Finally, we typically don't write programs in raw assembly anymore. Programmers can't be expected to drop down to assembly anytime they want to read a file or allocate memory. System calls are implemented differently across architectures. So operating systems provide an abstraction layer on top of these interrupts. Reusable higher-level library functions that wrap the necessary assembly instructions are provided by libc. What does this mean? It's new.
Corrupt Converter says before I head to basic, I need to learn how to swim LMAO.
Yeah, that sounds like a good plan to me.
Corrupt Converter says I technically don't, but I really should.
Yeah, I think that would be a good plan. Let me see. I guess this means library C. even see L-I-B. Oh, never mind. I see it now. Yeah, new. That's probably what it stands for. Library C. GNU or whatever. Hi. Hi, still needs work.
Needs work says hi.
Hope I'm not about to be marketed to right now. Where were they?
Corrupt Converter says, what is this BTW?
This is CPU land. But that's actually what it's called. It's called CPU land. See? It's CPU land. Oh wait, that's not the... I guess it doesn't show the link to it. It's CPU.land. Like, that's literally how it's accessed.
Still needs work says, oh, you study Japanese. Where did you learn Japanese?
No, you can just, there's plenty of resources available online and books and lots of things to learn from. But yeah, it's
Corrupt
CPU.
Converter says they learned Japanese from anime.
No, I don't watch anime actually. CPU.land.
Salttoserenity says CPU.land.
I'm part of a library called ntdll.dll on Windows. What is this?
Corrupt Converter says they learned Japanese so they could watch anime without subtitles.
Nah, they're lying.
Still needs work says I have the book The Five Rings in Japanese that I would like to one day read.
Oh, nice. NCDL. DLL. Oh, DLL stands for Dynamic Link Library. I had no idea what that was. NTZW entry points in the NTS kernel X. Oh my god. Okay. Calls to these library functions themselves don't cause switches to kernel mode. They're just standard function calls. Inside the libraries, assembly code does actually transfer control to the kernel and is a lot more platform dependent than the wrapping library subroutine. Cool. When you exit 1 from C, running on a Unix-like system, that function is internally running machine code to trigger an interrupt. After placing the system calls opcode and arguments in the right registers /stack /whatever. Computers are so cool. Cute. Placing system calls opcode. Oh yeah.
Still needs work says LOL.
That's true, they used to be people. Oh, well, that's kind of sad.
Corrupt Converter says, but we stripped that away from them.
Running on
Still needs work says computers used to be punch cards with people. Corrupt Converter says we no longer classify computers as people.
Let's see. The need for speed / let's get CISC. Many CISC architectures. What does this stand for?
Still needs work says I think some people are grateful that we no longer use punch cards.
Complex instruction set computer. Single instructions can execute several low-level operations, such as load from memory, capable of multi-step operations or addressing modes using single instructions. Oh, complex.
Still needs work says what are you trying to do?
Learn about assembly, learn a little bit about computers right now.
Corrupt Converter says they're trying to learn how to use a computer.
Damn. I'm back. Just an aspect of the instruction set architecture in most central processing unit designs. Define how the machine language instructions
Still needs
in the
work
architecture.
says what do you want to do with assembly language?
Nothing in particular, just complete corrupts challenges and get better at coding in general. Various addressing instruction set. In the architecture, identify the operands. Oh. That's interesting. Contain instructions as I'm called.
Corrupt Converter says they're simple tasks just to learn the very basics.
Yes. Corrupt is GLaDOS, Chell. Create it due to the prevalence of the system called Paradigm. Same instructions designed for system calls. Yes. Intel and AMD.
Corrupt Converter says I'm going to kill you.
Nah, isn't that my job? Because you know the tests are dangerous. Intel and AMD managed not to coordinate very well on x86-64. It actually has two sets of optimized system call instructions.
Still needs work says so just need to know the syntax then and what the commands do.
Then play? Oh, you mean like code? Yeah. Yeah.
Still needs work says you tinker with it.
It actually has two sets of optimized system call instructions. Syscall, syscenter, optimized alternatives to instructions like interrupt 80. Oh. Their corresponding return instructions, system return and system exit, are designed to transition quickly back to user space and resume program code. Interesting. AMD and Intel processors have slightly different compatibility with these instructions. Syscall is generally the best option for 64-bit programs, while sysenter has better support with 32-bit programs. Representative of the style, RISC architectures tend not to have such special instructions. What is a risk? Oh, reduced instruction set computer. Simplify. Are these still used? I'm only seeing like years like 1960, 1980 and stuff. High school. Who's artisan to have such special instructions? AER64, the RISC architecture Apple Silicon is based on, uses only one interrupt instruction for syscalls and software interrupts alike. Is the Apple Silicon like a name of a specific Apple computer? Probably. Apple Silicon. I think so. It's capitalized.
Corrupt Converter says the year is 2024. 69 years have passed since you were last awake.
Yeah. Yeah, isn't that something Wheatley says? Apple Silicon refers to system. System on a chip and system in a package processors. Oh, these are still used.
Still needs work says tutorials. Point has a tutorial on assembly language.
Yeah, I know, I've been going through it. See, it's right here.
Corrupt Converter says, yeah, guess which tutorial I recommended them.
Exactly.
Still needs
RISC
work says,
architectures
okay.
tend not to have such special instructions. For RISC architecture, Silicon based on uses only one instruction for syscalls and software interrupts alike.
Corrupt Converter says because the tutorial they were gonna use was shit.
Yeah, it was pretty bad though. That one that was linked to by Exorcism was like, they really didn't explain anything. I think Mac users are doing fine. Lol. Is this? I think they're being sarcastic here. Phew, that was a lot. Let's do a brief recap. Processors execute instructions in an infinite fetch execute loop and don't have any concept of operating systems or programs. The processor's
Still
mode
needs work says, oh, I thought you were
stored in
just
a
looking
register.
all over the internet for learning assembly.
Determines what instructions may be executed. Yeah, this site I found not from assembly. It's just how computers work. That's about it. But it's relevant to assembly because it talks about a lot of low-level stuff, which, you know, just crosses over well into assembly. So a lot of assembly.
Still needs work says, I didn't know you had a focal tutorial.
Focal tutorial? Oh, you mean like a main one? I was using. This is corrupt. Processors execute instruction. No, actually, he was saying that he thinks assembly was a waste of time, not to buy a book.
Still needs work says focused asterisk yeah main one.
Processor execute instruction. Oh yeah, the processor's mode, usually stored in a register, determines what instructions may be executed. Operating system code runs in kernel mode, switches to user mode to run programs. To run a binary, the operating system switches to user mode and points the processor to the code's entry point in RAM.
Still needs work says they teach machine language in CS, so saying it's a waste of time depends on what you want to do maybe.
I think that's a fair assessment. Work. Yeah, because sometimes you do, and right, when you actually take formal classes, you will learn about like computer architecture and like assembly and stuff like that. It's not a bad thing.
Corrupt Converter says it's not a waste of time IMO, the code, and language itself isn't the important part, the skills are.
The versus switch to user mode points the processor to the code's entry point in RAM. Now, because they only have the privileges of user mode, programs that want to interact with the world need to jump to OS code for help. System calls are a standardized way for programs to switch from user mode to kernel mode into OS code. Programs typically use these system calls by calling shared library functions. These wrap machine code for either software interrupts. Oh, thank you, whoever followed. Transfer control to the OS kernel and switch rings. Where'd my mouse go? Okay. I'm all time. I can't find my mouse. I can't find my mouse. Oh my god. Wait, this has happened before. I forgot how I fixed this.
Corrupt Converter says buy my course for free at a discount for $69,420,133.70 and learn all the nothing about assembly.
This is a freaking driver problem, probably. I hate this. Oh no. I have more problems like this in Windows, I swear to God. Okay, well, what to do? Hold on, I need to Google. I literally can't do anything right now because my mouse is gone. I think the last time this happened, I had to go to Task Manager and like close something. Or, I don't know. I don't even know what. Or I like just like delete it and reinstall. I think I might have deleted it and reinstalled a driver. Wait, but this... Wait, did it happen on this computer? Yeah, it did.
Still needs work says, is it a USB mouse?
No, it's my actual trackpad. It's a laptop. It's the actual, like, thing built into the computer. I know. It's annoying because you have to use...
Corrupt Converter says, well, the computer is still navigatable when your mouse doesn't exist.
It is, but it's really annoying to use the buttons to, like, do all the stuff. And now I have to Google and figure out how to do it again because I forgot how to...
Corrupt Converter says, but inconvenient.
Inconvenient as hell. Now, it's dumb. Okay, let's see. Windows R.
Still needs work says FN plus some key.
Okay, I'm in Device Manager. What is this? Wait, I might have accidentally pushed F5 or something, and then oh wait, no, that didn't help. Never mind. Try function F5. I'll try that. That also did not help.
Still needs work says on
Function
your keyboard.
F9. Oh wait, or function 7. Try that. That did not help at all. Wow, cool. Yeah, on my keyboard. It's gonna take some time to fix. I fixed this before, but it was a pain in the... It was a pain. Well, I'm in the device manager, so let's see. Where's mouse? Okay. I forgot the other stuff I have to do.
Corrupt Converter says your laptop has a pressure plate on the bottom that disables trackpad scroll.
Push between the tabs, you will see a dot square. If for some reason your tab is supposed to tab key from the keyboard. Oh wait, touchpad is a device. It should be a device. Where is it? Let's see. I don't see one called touchpad actually. Oh, I hate this. I should have bookmarked whatever that page
Corrupt
was.
Converter says I had this type of problem on my school Chromebook a bunch of times.
Oh yeah. That's annoying. I think I went to the wrong thing. Oh, how do I... Crap, how do I... I'm sorry again. Let's see. Through this. I think I can fix this. I hope I can fix
Corrupt
this.
Converter says but that was Chrome OS and a completely different device so.
Yeah, I see. Last time this happened was... It was a game that triggered this, but I'm not playing a game right now. It was like a buggy game that screwed up my driver. Oh wait, no, I'm on the right thing. What the heck? Oh damn, I opened another window. Tab once. Wait, no. Oh wait, yeah, mice and other pointing devices.
Corrupt Converter says keyboard navigation fun.
Super fun. Okay, so the thing is Oh wait, got it to open up. Oh, I got something. I got a menu to open up. The device is working properly? I don't think so.
Still needs work says what
Okay.
brand of laptop?
It's Asus. And I've had plenty of problems with this laptop, but it's what it is. How do I need to switch tabs. There we go. Okay, I will try to... Damn it. I have to start all over again. Okay. Driver... Tab. What did I do last time? See? Hey, got it back. Nice. Oh my god. I don't know why this... Okay. I knew it would just take some time. Like, I fixed it before. There's my mouse. That was random.
Still needs work says it says FNF6.
No, I don't think it's related to the function key at all. Wait a second. Did it just... Oh wait, now the whole...
Still needs work says okay.
Okay, now I can't even switch windows. Okay, something's obviously wrong right now with the OS. So I'm probably going to restart my computer, because like now I can't... Oh, wait, now it's working. What the heck? I lost my mouse again. Wait, no, now it's back again. Oh my god. So whenever I switch back to OBS... Anyway.
Corrupt Converter
Does
says
that mean
nice.
privileges? Or was I program cyclically used to calls? Shared library functions. Think. Go to this switch rings. Software architecture specific syscall instructions. The transfer control to the OS kernel and switch rings. The kernel does its business, switches back to user mode, and returns to the program code. Let's figure out how to answer my first question from earlier. If the CPU doesn't keep track of more than one process and just executes instruction after instruction, why doesn't it get stuck inside whatever program it's running? How can multiple programs run at once? See, the answer to this, my dear friend, is also the answer to why Coldplay is so popular. Clocks. Well, technically timers. I just wanted to shoehorn that joke in. I don't even get that joke. Slice that time. Let's say you're building an operating system and you want users to be able to run multiple programs at once without their mouses breaking. You don't have a fancy multi-core processor though, so your CPU can only run one instruction at a time. Luckily, you're a very smart OS developer. You figure out that you can fake parallelism by letting processes take turn on the CPU. Yeah, I heard that Python is like this too. Like, it's like fake parallelism. Like, it doesn't actually have multi-threading, but it can do something that looks like it. If you cycle through the processes...
Still needs work says so it has non-dependent instructions because of the hardware run at the same time.
Non-dependent instructions because yeah, I don't know what you mean. I think it says non.
Still needs work says that was awful sorry.
Oh, don't worry. I think they're just saying that there's using an example like of a computer that can only do one thing at a time. So if you switch between doing multiple things at the same time, it looks like you're doing both of them together because you're switching so fast between both. Apparently, that's how the human brain works. Apparently, you can't actually multitask, but you can just switch between doing two things very, very quickly. So I've heard. You're very smart, Jeff. Figure out that you can fake. Oh yeah, if you cycle through the processes and run a couple instructions from each one.
Still needs work says I mean that two instructions can run at the same time because those two instructions are not dependent on the other.
Yeah, but here they're saying in this example, the computer can only process one at a time. So even though, you can have instructions that are independent of each other, the computer has to take turns switching between them instead of running both at the same time because you have one core. You don't have more cores to do more things at the same time. Cycle through the processes and run a couple instructions from each one. They can all be responsive without any single process hogging the CPU. But how do you take control back from program code to switch processes? After a bit of research, you discover that most computers come with timer chips. Interesting. You can program a timer chip to trigger a switch to an OS interrupt handler after a certain amount of time passes.
Still needs work says Intel has tech I believe to allow for parallel instruction running.
Yeah, in this case, it's fake parallelism, but
Still
they're
needs
giving a
work says
specific
meaning
example.
that two run at the same time.
Yeah, nowadays you have computers with multiple cores, but they're just using a very basic example of a computer with one core right now. Hardware interrupts. Yeah. Earlier we talked about how software
Still
interrupts
needs work says example of one core
are used to hand control from a userland program to the OS. These are called software interrupts because they're voluntarily triggered by a program. Machine code executed by the processor in the normal fetch execute cycle tells it to switch to the kernel. Interrupt triggers context switch. I'm not sure why this key is like colored yellow. OS schedulers use timer chips like pits to trigger hardware interrupts for multitasking. That's cool. A counter that generates an output signal when it reaches a program count. So there's clocks that are built into the chips, basically. That can help. That a computer can like fake parallelism with the clocks. The output signal may trigger an interrupt. So this is where like electrical engineering like goes into computer science. Before jumping to program code, the OS sets the timer chip to trigger an interrupt after some period of time. The OS switches to user mode and jumps to the next instruction of the program. When the timer elapses, it triggers a hardware interrupt to switch to kernel mode and jump to OS code. The OS can now save where the program left off, load a different program, and repeat the process. This is called preemptive multitasking. The interruption of a process is called preemption. If you're, say, reading this article on a browser and listening to music on the same machine, your very own computer is probably following this exact cycle thousands of times a second. Ooh. Time slice calculation. A time slice is the duration an OS scheduler allows a process to run before preempting it. The simplest way to pick time slices is to give every process the same time slice, perhaps in the 10 millisecond range, and cycle through tasks in order. This is called fixed time slice round-robin scheduling. Aside fun jargon facts. Did you know that time slices are often called quantums? Now you do, and you can impress all your tech friends. I think I deserve heaps of praise for not saying quantum in every other sentence in this article. Speaking of time slice jargon, Linux kernel devs use the Jiffy time unit to count fixed frequency timer ticks. Among other things, Jiffies are used for measuring the length of time slices. Linux Jiffy frequency is typically 1000 Hz, but can be configured when compiling the kernel. Hertz. This is like electricity, isn't it? Hertz are used for electricity, I think, right? Hertz. I thought it was like frequency or... Oh. How does this tell when it interrupts? Oh, speed? Oh, like the way...
Still needs work says it's speed of cycles.
Oh, like it makes like a Oh. They're like using that.
Corrupt Converter says I'm back, what did I miss?
No, just looking at Hertz. You missed quantums, that's what you missed. That time slices are often called quantums. Now you can impress, says it. Now you can impress all your tech friends. It hurts, yes. It hurts.
Corrupt Converter says it hurts.
Where was I? Oh yeah, frequency. Frequency is measured in hertz. You're right. You were right about that. 1000 hertz. I don't know. Well, now I know it's used for frequency, but equivalent to one event or cycle per second. So 1 hertz means 1 per second. 1000 means probably 1000 per second. So 1,000 times per second, it's able to switch to another program and run instructions. It's kind of insane. I think a slight improvement to fixed time slice scheduling is to pick a target latency, the ideal longest time for a process to respond. The target latency is the time it takes for a process to resume execution after being preempted, assuming a reasonable number of processes. This is pretty hard to visualize. Don't worry, a diagram is coming soon. Time slices are calculated by dividing the target latency by the total number of tasks. This is better than fixed time slice scheduling.
Corrupt Converter says modern CPUs do much more than 1,000 instructions per seconds.
I know. 1,000 seems fast, but modern CPUs are kind of insane. Like, computers are pretty small, aren't they? Like, damn. I wish my brain could do 1,000 calculations per second. But, like, not dumb ones. Target latency by the total number of tasks. This is better than fixed time slice scheduling
Corrupt
because
Converter says like trillions or something.
Oh my god. Because it eliminates wasteful task switching with fewer processes. I'm trying to imagine this target latency by the total number of tasks. Because this is like
Corrupt
simple math.
Converter says I don't know exactly what it is.
Simple math. Let me think about this. If I think about this for like a minute or something, I feel like I could understand it better. Because something divided by number of tasks. Why was this? And it makes it more efficient than just fixed time periods. I guess because the latency is like evenly divided among them, so that you don't have, you don't waste too many resources.
Still needs work says I need to lurk for a bit while I work on my class.
Oh yeah, that's fine. This is a study stream after all, so it's good when other people study. What are they doing?
Corrupt Converter says, unlurk at still needs work.
Is that an actual Twitch command? Or something? Or just a joke? Exclamation point lurk. Fixed total number of tasks. Oh yeah. With the target latency, they're going to use an example. With the target latency of 15 milliseconds, and 10 processes. Each process would get 15 divided by 10, or 1.5 milliseconds to run.
Corrupt Converter says I don't know yet what is the point of lurk.
There's only 3 processes. Each process gets a longer 5 millisecond time slice while still hitting the target latency. Wow, it seems simple, but the math's kind of confusing. Only 3 processes. Longer 5 ms time slice. I'll come back to this in a second. There is a drawing, so I'll just look at the drawing. Maybe it will help. Process switching is computationally expensive because it requires saving the entire state of the current program and restoring a different one. Past a certain point, too small a time slice can result in performance problems with processes switching too rapidly. It's common to give the time slice duration a lower bound, minimum granularity. This does mean that the target latency is exceeded when there are enough processes for the minimum granularity to take effect. At the time of writing this article, Linux's scheduler uses a target latency of 6 milliseconds and a minimum granularity of 0.75 milliseconds. What? Neither dynamic time steps for longer scheduling. 2 milliseconds. 6. 3, 4, 5, 6. I wish they had a picture of fixed time slicing so I could compare what they look like. 15. The ideal longest time for a process to respond. Ideal longest. Oh, 3 processes is like 15 divided by 3, which is 5. Oh! I think it's starting to make sense. Because the latency is like... It's like your total time amount that you want before you'll access whatever you stored away again, I guess. Too small a time scale. Switching too rapidly. Makes sense.
Corrupt Converter says this is all stuff that you're gonna need to know when you're
Hell
coding
yeah.
in copper rails and transistors.
Need to get my transistors. This does mean that target latency exceeded when we're in a process for minimum granularity. So the minimum granularity. Oh, lower bound. Oh, that's when you're like switching like 0.5 ms and switching so fast between programs that they run like crap. Round robin scheduling with this basic time slice calculation is close to what most computers do nowadays. It's still a bit naive. Most operating systems tend to have more complex schedulers, which take process priorities and deadlines into account. Since 2007, Linux has used a scheduler called Completely Fair Scheduler. Wow. Completely Fair Scheduler does a bunch of very fancy computer science things to prioritize tasks and divvy up CPU time. Every time, and I bet it's very mathy too, every time the OS preempts a process, it needs to load the new program's saved execution context, including its memory environment. This is accomplished by telling the CPU to use a different page table, the mapping from virtual to physical addresses. Virtual to physical. This is also the system that prevents programs from accessing each other's memory. We'll go down this rabbit hole in chapters 5 and 6 of this article. Kernel preemptibility. So far, we've been only talking about the preemption and scheduling of userland processes. Kernel code might make programs feel laggy if it took too long handling a syscall or executing driver code. Oh yeah, because it runs driver code too. Modern kernels, including Linux, are preemptive kernels. This means they're programmed in a way that allows kernel code itself to be interrupted and scheduled just like userland processes. This isn't very important to know about unless you're writing a kernel or something, but basically every article I've read has mentioned it, so I thought I would too. Extra knowledge is rarely a bad thing. Note number 2, a history lesson. Ancient operating systems, including classic macOS and versions of Windows long before NT, used a predecessor to preemptive multitasking. Rather than the OS deciding when to preempt programs, the programs themselves would choose to yield to the OS. They would trigger a software interrupt to say, hey, you can let another program run now. Oh wow, so the programs were in control, not the actual OS. These explicit yields were the only way for the OS to regain control and switch to the next scheduled process. That sounds very bad. This is called cooperative multitasking. It has a couple major flaws. Malicious or just poorly designed programs can easily freeze the entire operating system, and it's nigh impossible to ensure temporal consistency for real-time/time-sensitive tasks. For these reasons, the tech world switched to preemptive multitasking a long time ago and never looked back. Ooh. What's this code? Oh, this is C. H. What is it? I guess this one's not C. So far we've covered how CPUs execute machine code loaded from executables, what ring-based security is, and how syscalls work. In this section, we'll dive deep into the Linux kernel to figure out how programs are loaded and run in the first place. We're specifically going to look at Linux on x86-64. Why? Linux is a fully featured production OS for desktop, mobile, and server use cases. Linux is open source, so it's super easy to research just by reading its source code. I'll be directly referencing some kernel code in this article. x86-64 is the architecture that most modern desktop computers use, and the target architecture of a lot of code. The subset of behavior I mentioned that is 86-64 specific will generalize well. Most of what we learn will generalize well to other operating systems and architectures, even if they differ in various specific ways. Exec system calls. Instead of binary. Bin FMT. Let's start with a very important system call, execve. Where is that one show? Up here. It loads a program, and if successful, replaces the current process with that program. A couple other syscalls, exec lp, exec vpe, etc. exist, but they all layer on top of execve in various fashions. Aside, execveat. Execve is actually built on top of execveat, a more general syscall that runs a program with some configuration options. For simplicity, we'll mostly talk about execve. The only difference is that it provides some defaults to execveat. Curious what VE stands for? The V means one parameter is the vector list of arguments, argvector, And the E means another parameter is the vector of environment variables. Environment. V. Oh yeah, an E. Oh. Variables. Various other exec syscalls have different suffixes to designate different call signatures. The AT in exec VEAT is just at. It specifies a location to run exec VE at. Oh. The call signature of exec VE is interrupt exec VE character file name. The file name argument specifies a path to the program to run. Argument variable is a null terminated, meaning the last item is a null pointer list of arguments to the program. The argument what's again? Argv? Oh, vector arguments. V. Last item is a null pointer list. Null arguments of the program. The argc. Huh. Oh, I think I've seen this in like the main function or whatever for C. Like this was in there. You'll commonly see passed C main functions is actually calculated later by the syscall, thus the null termination. Not that long ago, but it was
Corrupt
here.
Converter says you've seen this 69
Now I'm
years
gonna do that
ago.
second.
Oh wait, I guess I'm tripping. That just says void. Never mind. I thought I remembered there was like argc here, but no, sadly. But maybe it was like, I think I did. I think it wasn't in this video, but the previous one, he like showed a sample of like C code, and there was something in there. I think that's what it's talking about. Null terminated list of environment variables. Wait, what were they? Oh yeah. Calculated later by the syscall. That's a null termination. Interesting. Why would that need to... Later by the syscall. Okay. The environment parameter, I think that's what it said. Variables. Argument contains another null terminated list of environment variables used as context for the application. They're conventionally key equals value pairs. Conventionally. I love computers.
Corrupt Converter says you used to work for DARPA but then you fucked up and got either neuralized or administered amnestics. That's why you're in 4th grade now.
Okay. Let's keep on. Fun fact, you know that convention where a program's first argument is the name of the program? That's purely a convention, and isn't actually set by the exec VE syscall itself. The first argument will be whatever is passed to exec
Corrupt
V.
Converter says, Both of those mean memory was wiped.
Okay. Where's best exec v is the first. It's the first item in the argument variable argument, even if it has nothing to do with the program name. Oh. Interestingly, exec VE does have some code that assumes variable 0 is the program name. More on this later when we talk about interpreted scripting languages. Name of the program. Interesting.
Corrupt Converter says, or whatever the hell happened in that episode of Doctor Who,
Step 0.
the first episode where the real actual Clara
Definition.
Oswald came in.
We already know how syscalls work, but we've never seen a real-world code example. Let's look at the Linux kernel source code to see how exec.ve is defined under the hood. Exec.c. Syscall define user file name. So const user. I don't know what these little star things are. I do not know C. Value const character user const user. Environment argument.
Corrupt Converter says usually it means pointer.
Oh, that's cool. Pointer. File name. Okay. Const user. Weird.
Corrupt Converter says I'm not sure 100% if it means that here because I don't know much C.
But it could mean pointer. That's really useful to know. Because I haven't really seen star before in anything. That's cool. Return do exec.ve get name file name. Valid environment per environment arguments. Syscall define 3. I guess there's 3 things or something. The macro for defining a 3-argument system calls code. Interesting.
Corrupt Converter says, well, it's also the multiplication symbol, so you're lying.
Oh yeah, I am lying. Oh damn it. Well, you're right, but they're not multiplying here, so. Yeah. Syscall define 3 is a macro for defining. I guess I meant in this context where it doesn't look like multiplication. I was curious why the arity is hard-coded in the macro name. It is? What is an arity? Oh my god, in logic, mathematics, and computer science, arity is the number of arguments or operands taken by a function. Wow. Okay. Operand is the object of a mathematical operation. Okay. Number. So fancy. Pointers.
Corrupt Converter says C.
Oh, unsafe code. That's cool. It sounds fun. And I feel like after I play with assembly, like, I'll have fun, like, getting to play with pointers and C, because it's like something like that. Hard code it in the macro name. Yeah. I googled around and learned that this was a workaround to fix some security vulnerability.
Corrupt Converter says yeah, when you do assembly, pointers will make a lot of sense.
That's cool. I've wanted to learn about pointers for so long, honestly. But I was always like intimidated because it's like, oh, pointers are like advanced programming, and then everyone's always like, don't mess with pointers, like it's too hard and stuff. Like, I don't know. Just use a language with garbage collection. It's easier.
Converter says spit.
Not them, but just in general, people say that. Macro name. Still work on fix some security vulnerability. The file name argument is passed to a getName function. Which copies the string from user space to kernel space and does some usage tracking things. It returns a file name structure. I guess that's what this is doing, maybe. Oh, it's doing it. Returns a file name structure, which is defined in include linux fs.h. Stores a pointer to the original string in user space as well as a new pointer to the value copied to kernel space.
Corrupt Converter says I'm gonna use Spit's likeness as the meme whenever the context is someone telling you that you shouldn't do or use something in code, unless it's for really good reason.
Oh my gosh. No, but I bet they were just trying to be helpful. That's what I think. Like I said, they were really nice. Well, they were nice enough to send me some like helpful resources, so yeah, we shouldn't come down on Spet. It's original string. Yeah. File name structures defined in. This is a structure, I guess. File name structure. New pointer to the value copy to kernel space. File name. That's cool. Constant character. Name. Yeah, this is a pointer. You were right. The star thing, star name is a pointer. Pointer to actual string. Const user character. Oh wait, this user thing, it probably means user space. User space. User space. Probably. Or something. Pointers. So interesting. Constant user char. UPTR. Original userland pointer. Oh, it stands for user pointer. Interrupt. Ref. I forgot, what is it? What does that stand for again? Ref. Return. They literally talked about it on the last page too. I forgot again, no. No? Is the last page previous? Ref. Am I tripping? swear to God they had that.
Corrupt converter says don't learn assembly, it will kill you and sue you.
Ref. What? I swear to God that showed up. Or they talked over. No way was it on the first page. Yeah, I thought, but like, what? I swear I was like reading about it just a second ago. Well, not that long.
Corrupt converter says and it'll take your skin.
Not here. What? Who's down here? Oh, this. But this. Oh, this was return. Interrupt and interrupt return. Never mind. I've never seen ref before. Probably like reference though. Oh my God, there's so much about the code. What are the other? I kind of want to just preview what the other sections are like. Oh Lord. This one's not bad. What's this? Wow. Oh no, GPT was consulted as a source. It's okay. Okay, where was I? Pointer to actual string. Original userland pointer. FCNT. Audit names. Name. My name. The execve system call then calls the do execve function. This in turn calls do execve at common with some defaults. The execveat system call, which I mentioned earlier, also calls do execve at common, but passes through more user-provided options. In the below snippet, I've included the definition of both do execve and do execveat. So static and do execve. Structure file name. Discover user constant users. Argument. Where I think they were all argument vectors. Yes. I don't know. Okay, now my mouse is stuck. Oh, great. Now my mouse is gone again. Let me see. Actually, messing with the function keys does help. I don't know why this happens though. User, constant user, environment, argument. Structure, user arg, ptr, argument, vectors. Well, still no idea what this is. Term, do accept VEAT common. ATFDCWD file name, argument variables, environment, argument. Static. I guess this is actually like int. Oh no, do accept VEAT. First I thought these were interrupts, but maybe that's just an actual int. I do not know. FD name, user, same stuff. Flags. So just like more stuff. Spacing sick. What is that? An exec VAT, a file descriptor, type of ID that points to some resource, is passed to the system call, and then to do exec VAT common. File descriptor. Is this the file name? Or maybe it says at thing. No, FD. Because for this one only. File descriptor. It specifies the directory to execute the program relative to. In execve, special value is used for the file descriptor argument at fdcwd. This is a shared constant in the Linux kernel. That tells functions to interpret path names as relative to the current working directory. Functions that accept file descriptors usually include a manual check like if file descriptor is equal to at fdcwd special code path. File descriptors. Oh. Step 1 setup. We've now reached to exec VAT common, the core function handling program execution. We're going to take a brief step back from staring at code to get a bigger picture view of what this function does. The first major job of do exec VAT common is setting up a structure called Linux binprm. I won't include a copy of the whole structure definition, but there are several important fields to go over. Data structures like structs and VM area structs are defined to prepare virtual memory management for the new program. C and environment arguments are calculated and stored to be passed to the program. File name and interp store the file name of the program, this internal pointer, and its interpreter. Oh, interpreter, respectively. These start out equal to each other, but can change in some cases. One such case is when running interpreted scripts with a shebang.
Corrupt converter says Intwerp.
Shebang. Intwerp. Unix. This is a shebang. Consisting of the character hash exclamation mark. I have never. I did not know that. Can change in some cases. TurboScript with a shebang. When executing a Python program, for example, file name points to the source file, but interpreter is the path to the Python interpreter. BUF is an array filled with the first 256 bytes of the file to be executed. It's used to detect the format of the file and load script shebangs.
Still needs work says, are you going to pursue a degree in CS?
Not right now. Degrees cost money. Array files first bytes. Today I learned BINPRM stands for binary program. Oh. Format of the file. Let's take a look at this buffer. That's what that is. Next stop, binary program. Binary formats. Buffer size. As we can see, its length is defined as the constant binary program buffer size. By searching the codebase for the string, you can find a definition for this and include UAPI Linux binary format H. So the kernel loads the opening 256 bytes of the executed file into this memory buffer. Aside, what's a UAPI? You might notice that the above code's path contains UAPI. Why isn't the defined length in the same file as a Linux binary program structure? Include Linux binary formats.h. What are these names again? Oh yeah, here. UAPI stands for User Space API. In this case, it means someone decided that the length of the buffer should be part of the kernel's public API. In theory, everything UAPI is exposed to userland, and everything non-UAPI is private to kernel code. Kernel and user space code originally coexisted in one jumbled mass. 2012, UAPI code was refactored into a separate directory as an attempt to improve maintainability. Step 2. Binary formats, yeah. The kernel's next major job is iterating through a bunch of binary formats handlers. These handlers are defined in files like as file structure binary format alf.c and file structure binary format flat.c. Kernel modules can also add their own binary format handlers to the pool. Each handler exposes a load binary function. Yes.
Corrupt Converter says, are you going to pursue a degree in JDoodle?
I am going to pursue a degree in JDoodle. For sure. You got your degree from JDoodle, so shall I. I'll try to. Iterate through a bunch of binary format handlers. These handlers are defined in files like file system binary format. Oh wait, I just read that. Each handler exposes a load binary function which takes a Linux binary program structure and checks if the handler understands the program's format.
Corrupt Converter says low price of $2,147,483,647.
This often involves looking for magic numbers in the buffer, attempting to decode the start of the program, also from the buffer. Magic numbers. Ooh. Decode the start of the program. /or checking the file extension. If the handler does support the format, it prepares the program for execution and returns a success code. Otherwise, it quits early and returns an error code. The kernel tries to load binary function of each binary format until it reaches one that succeeds.
Corrupt Converter says, what's magic numbers?
Probably like a sequence of numbers that identifies what kind of program it is so that it can be run or something. That's my guess. But that's kind of interesting. It basically just brute forces this and tries a bunch of these handler things until it can load the program. Doesn't that seem inefficient? Sometimes these will run recursively. For example, if a script has an interpreter specified and that interpreter is itself a script. I don't know.
Corrupt Converter says, what's the link say about them?
I don't want to read it. But it's obviously a special kind of value. So. See? Just like what it sounds like. Identify file format protocol. The kernel tries to load binary function with. If a script has an interpreter specified and that interpreter is itself a script, the hierarchy might be binary format script. Binary format script. Oh, binary format ELF, where ELF is the executable format. Oh, executable format at the end of the chain. The interpreter itself is a script. Oh, damn. ELF is executable format. Huh. Format highlight scripts. Of the many formats Linux supports, binary format script is the first I want to specifically talk about. Have you ever read or written a shebang? That line at the start of some scripts that specifies the path to the interpreter? I always just assumed these were handled by the shell, but no. Shebangs are actually a feature of the kernel, and scripts are executed with the same system calls as every other program. I know, I like it a lot.
Corrupt Converter says shebang is such a silly name.
Computers are so cool. Scripts execute the same system calls of every other program. Take a look at how file system binary format script.c checks if a file starts with a shebang. Not ours to execute if we don't start with shebang. if BP or if binary program buffer 0 not equal to shebang, binary program or binary program buffer 1 not equal to exclamation mark return no execute. The file does start with the shebang. The binary format handler then reads the interpreter path and any space separated arguments after the path. Space separate arguments. It stops when it
Corrupt
hits.
converter says if first character not.
Yeah, not equal. Yeah, that'll be the first one. Second one. It stops when it hits either a new line or the end of the buffer. There are two interesting wonky things going on here. First of all, remember that buffer in Linux binary program that was filled with the first 256 bytes of the file? Yeah, that's used for executable format detection, but that same buffer is also what shebangs are read out of in binary format script. Shebangs. It seems like overly complicated. During my research, I read an article that described the buffer as 128 bytes long. At some point after that article was published, the length was doubled to 256 bytes. Curious why. Wait, byte? Oh, whoever followed, thank you. Doesn't a byte hold like one character in it in ASCII or something? Or is it less? Is it a byte? What's the size? Oh yeah. Yeah, that doesn't seem very long. 256.
Corrupt converter says yes.
Cool. Doesn't 256 characters seem kind of short for this purpose? Shouldn't it be like infinite characters? Curious why, I checked the git blame, a log of everybody who edited a certain line of code, for the line where binary program buffer size is defined in the Linux source code. Git blame. Well, I've heard of this, but everybody has a certain line of code. Lo and behold, Jesus, it's long. 256. Large enterprise clients often run applications out of networked file systems, where the IT mandated layout of product volumes can end up leading to paths that are longer than
Corrupt
128
converter
characters.
says TDS.
Yes.
Corrupt converter says
For
it's
infinitely many reasons, yeah. Good one. Often run network
Corrupt
file
converter
system.
says it didn't read the other message for some reason.
Bumping this up to the next order to solve this problem. Well, since it's hosted by like someone else with their own like server or whatever, like it can. I'm sure it can just be like, you know, iffy sometimes. In the past, it used to like shut down all the time, but now it doesn't do that anymore. So they fixed their crap. Bumping this up to the next order of 2 solves this problem in all but the most egregious case, while still fitting into a 512 byte
Corrupt
slab.
converter says host it yourself.
That takes knowledge of. It'd be fun to make a TTS bot though. I'd like that, but yeah, I need knowledge of how to make this up to the next order of 2, and all but the most egregious case. 512 byte. Oh my god, not again. Computers are so cool. Since shebangs are handled by the kernel,
Corrupt Converter says create a TDS bot
and
in assembly.
From hell no. Pull it from buffer instead of loading the whole file. They're always truncated to the length of buffer. Apparently, 4 years ago, someone got annoyed by the kernel truncating their 128 character pass. Oh, this is because this is like the file, like the pathway of the file, like not going over a certain amount. Like I think even Windows has a limit where it says like the name's too long. Like if you use too many characters and names of like folders and stuff, and like keep putting more stuff into more folders and folders. Maybe that's what this is all about. And their solution was to double the truncation point by doubling the buffer size. That's a good solution. Today, on your very own Linux machine, which I don't have, if you have a shebang line more than 256 characters long, everything past 256 characters will be completely lost. Wow. Okay. Imagine having a bug because of this. Imagine trying to figure out the root cause of what's breaking your code. Imagine how it would feel discovering that the problem is deep within the Linux kernel. Woe to the next IT person at a massive enterprise who discovers that part of a path has mysteriously gone missing. The second wonky thing. Remember how it's only convention for argument vectors 0 to be the program name? Why do they call it a vector if it's just a list of stuff? I don't understand why they use the word vector. Program name, how the caller can pass any argument vector they want to an execute system call. And it will pass through unmoderated. It just so happens that binary format script is one of those places that assumes argument vector 0 is the program's name. It always removes argument vector 0 and then adds the following to the start of argument vector. Oh. Path to the interpreter. Arguments to the interpreter. File name of the script. Interesting. Example, argument modification. Let's look at a sample exec.ve call. Script ABCD. This hypothetical script file has the following shebang as its first line. Node. Experimental module. The modified argument vector finally passed to the node interpreter, called node, will be that's script BC. Oh, wow. After updating argument vectors, the handler finishes preparing the file for execution by setting Linux binary program interpreter to the interpreter path. In this case, the node binary. Finally, it returns 0 to indicate success preparing the program for execution. Oh. Not the Linkin Park song. Format, highlight, miscellaneous interpreters. Another interesting handler is binary format miscellaneous. It opens up the ability to add some limited formats through userland configuration. When mounting a special file system at proc system file system binary format miscellaneous. Programs can perform specially formatted writes to files in this directory to add their own handlers. Each configuration entry specifies how to detect their file format. This can specify either a magic number at a certain offset or file extension to look for, the path to an interpreter executable. There's no way to specify interpreter arguments, so a wrapper script is needed if those are desired. Some configuration flags, including one specifying how binary format miscellaneous updates argument vector. Files directory. This binary format miscellaneous system is often used by Java installations, configured to detect class files by their Cafe Babe, Magic Bytes, and jar files by their extension. On my particular system, a handler is configured that detects Python bytecode by its .pyc extension and passes it to the appropriate handler. This is a pretty cool way to let program installers add support for their own formats without needing to write highly privileged kernel code. In the end, not
Corrupt converter says PYC, XQC, DVD,
PVC. An executive system call will always end up in one of two paths. It will eventually reach an executable binary format that it understands, perhaps after several layers of script interpreters, and run that code. At this point, the old code has been replaced. Or it will exhaust all its options and return an error code to the calling program, tail between its legs. If you've ever used a Unix-like system, you might have noticed that shell scripts run from a terminal still execute if they don't have a shebang line or .sh extension. That's because that's probably shell. You can test this out right now if you have a non-Windows terminal handy. I don't. Interesting. Extension. Go hello file. Hello. chmod x, which tells the OS that a file is executable. Where's that? Oh. Won't be able to run it otherwise. Interesting. So why does the shell script run as a shell script? The kernel's format handlers should have no clear way of detecting shell scripts without any discernible label. Well, it turns out that this behavior isn't part of the kernel. It's actually a common way for your shell to handle a failure case. Oh. When you execute a file using a shell and the executive system call fails, most shells will retry executing the file as a shell script, executing a shell with the file name as the first argument. Bash will typically use itself as this interpreter, while ZSH uses whatever SH is, usually Bourne shell. This behavior is so common because it's specified in POSIX, an old standard designed to make code portable between Unix systems. While POSIX isn't strictly followed by most tools or operating systems, many of its conventions are still shared. An executive system call fails due to an error equivalent to the no execute error. The shell shall execute a command from this, equivalent to having a shell invoked with the command name as its first operand. With any remaining arguments passed to the new shell. If the executable file is not a text file, the shell may bypass this command execution. In this case, it shall write an error message, shall return exit status 126. Huh. So this is like the file name? Oh, Lord. Why is this so Linux focused? We pretty thoroughly understand execve now. At the end of most paths, the kernel will reach a final program containing machine code for it to launch. Typically, a setup process is required before actually jumping to the code. For example, different parts of the program have to be loaded into the right places in memory. Each program needs different amounts of memory for different things, so we have standard file formats to specify how to set up a program for execution. While Linux supports many such formats, the most common format by far is ELF, executable and linkable format. Oh, that's probably what the DLL stuff is. Because it has, one of them was like linking library or something. Put it off on shelf before ELF on a new Linux. I think it's just the kernel. The operant systems. Are elves everywhere? When you run an app or command line program on Linux, it's exceedingly likely that it's an ELF binary. However, on Mac OS, the de facto format is Macho instead. Macho does all the same things as ELF, but is structured differently. On Windows, execution files use the portable executable format, which is again a different format with the same concept. In the Linux kernel, ELF binaries are handled by the binary format ELF handler. I already forgot what ELF stood for. Oh wait, it was executable and linkable format, which is more complex than many other handlers and contains thousands of lines of code. Oh my god.
Corrupt Converter says it's probably
Oh,
Linux
yeah.
focused because it's likely mostly Linux users who need to care about these
That's
things.
why all this stuff is usually like talks about Linux by default. That's a good point, because Microsoft and like Apple take care of their own stuff, and then the user, people who work on them, don't have to deal with this. But then people who use Linux, because it's all open source, like are doing. That's a good point. parsing. Oh man, 10,000 is code.
Corrupt Converter says, and also yeah, Linux is open source.
Yeah. That's pretty cool, considering like all this stuff is like, you know, like you can get like it's crazy that you can like mess with like actual like kernel code. That is pretty cool. It's pretty cool. But there's so many ways I can see things going wrong. It's just more than other thousands of lines of code. It's responsible for parsing out certain details from the ELF file and using them to load the process into memory and execute it. I ran some command line kung fu to sort binary format handlers by line count. Oh, nice. Kung fu. Sort CMD. This is how many lines there are? 2,181 lines. Oh, flat.c, C script. ELF test. Let's see. That's a lot of lines.
Corrupt Converter says, is this all sticking to your brain?
I don't know. But the more I read, the less intimidating assembly feels. But it's cool to see how, like, have an idea of, like, ways that, you know, the code that people write actually communicates with the operating system and with the kernel.
Corrupt Converter says, the less what?
Less what? Before looking more deeply at how binary format ELF executes ELF files, let's take a look at the file format itself. ELF files are typically made up of 4 parts: header, basic information about the binary, and locations of PHT and SHT, which I have no idea what those are.
Corrupt Converter says, the less something assembly feels. I didn't hear you.
I said the more I read... Oh yeah, I said the more I read about things like this, about lower level things and kernels and assembly and all those kinds of things, less intimidating assembly feels. You know, getting used to seeing things that I don't entirely understand. Program header table. Oh, that's what PHT is. Describes how and where to load the ELF file's data into memory. How and where? Okay. Section header table. Optional map of the data to assist in debugging. Oh. Data. All the binaries data. The PHT and SHT point into this section. Wow. ELF header. Every ELF file has an ELF header. Has the important job of conveying basic information about the binary, such as what processor it's designed to run on. ELF files can contain machine code for different processor types, like ARM and x86. What uses ARM, anyway? Oh wait, doesn't Mac does. Mac x86? I think it does. Wait, didn't it say that earlier? Yeah, this was for Mac. CISC approach.
Corrupt Converter says, almost everybody uses ARM. Most people use 2 of them.
Oh, really? Oh, bruh. So this one must be like Mac, this one must be like Windows. So they're like... I guess that means Mac and Windows have like very different architectures. Because I think what I saw earlier when I opened a link was it said like Mac and Apple systems and stuff, Apple processors are based on ARM. Whether the binary is meant to be run on its own as an executable, or whether it's meant to be loaded by other programs as a dynamically linked library. Hey, that's DLL. Oh, DLLs are meant to be loaded by other things. We'll go into details about what dynamic linking is soon. That's good, because DLL shows up a lot on Windows. And all those Unity files have DLL too. It says DLLs everywhere. The entry point of the executable. Later sections specify exactly where to load data contained in the ELF file in the memory. The entry point is a memory address pointing to where the first machine code
instruction. Think of Windows
instruction.
as a dog and Mac as a llama.
But llamas are more cool. Shouldn't Windows be the llama? The entry point, not llama. It's memory address pointing to where the first machine code instruction is in memory. Oh yeah. After the entire process has been loaded. Yeah.
Corrupt Converter says the entry llama LUL.
Address. The ELF header is always at the start of the file. It specifies the locations of the program header table and section header, which can be anywhere within the file. Those tables in turn point to data stored elsewhere in the file. Program header table. The program header table is a series of entries containing specific details for how to load and execute the binary at runtime.
Casper 17 says hello.
Hello. Each entry has a type field that says what detail is specifying. For example, PT load. What was PT again? Program.
Casper Caper 17 says it's 8:30 here, my friend.
Means it contains data that should be loaded into memory. But PT note means the segment contains informational text that shouldn't necessarily be loaded anywhere. Ah. What detail specifying? PT load data to be loaded in memory. PT note freeform text like copyright
Corrupt Converter
notices,
says stream started
info,
2.5 hours ago.
PT
You're 2
dynamic
hours
info
25
about
minutes
dynamic
late.
Linking. PT interpreter path to the location of an ELF interpreter. Freeform text like copyrights. Oh yeah, header. Each entry specifies information about where its data is in the file, and sometimes how to load the data into memory. It points to the position of its data within the ELF file. It can specify what virtual memory address the data should be loaded into memory at. This is typically left blank if the segment isn't meant to be loaded into memory. So now we're talking about registers again.
Casper Caper 17 says if I had to see every minute of these streams I would have to clear my diary.
Which data should be loaded into memory at? I think you mean calendar, by the way. No, it should be loaded into memory at. Blank segment isn't meant to be loaded. Because segment, this is like parts, this is like areas where the
Corrupt Converter says see
registers.
This is like the excuses people give to not clean their room.
Registers are divided. Virtual memory address data should be loaded into memory at. If the segment isn't meant to be loaded into memory. Clear your diary. Two fields specify the length of the data. One for the length.
Casper Caper 17 says I have to give a training to the mentors for the Eunice introductory period in 1,5 hours, so he'll have to go in 20 or so minutes.
Oh, okay. That sounds fun. Well, that sounds interesting. Lecture. One for the length of data. Oh yeah. Two fields specify the length of data. One for the length of data in the file. One for the length of the memory region to be created. If the memory region length is shorter than the length in the file, the extra memory will be
Casper
filled
Caper
with
17
zeros.
says I think diary is British English, whereas calendar is American English.
That's possible. In American English, diary is a journal you keep at the end of, like, you just rewrite about how your day was. Like, you do it, like, at the end of the day. Two. Length of data.
Corrupt Converter says diary is for wimpy kids.
Length is longer than the length in the file. The extra memory will be filled with zeros. This is beneficial for programs that might want a static segment of memory to use at runtime. These empty segments of memory are typically called BSS segments. Bro, that's like in assembly. The
Casper Caper 17 says diary can mean both calendar or the American meaning in Britain.
That's just like the BSS section in assembly, right? I still have this open. The BSS. It shows up again. I'm glad it is. So these are empty segments of memory. Like extra stuff. Well, at least in this case. That's cool. Block starting symbol.
Corrupt Converter says we should use a one-word language and make that one word able to mean anything.
People have already done that. Finally, a flags field specifies what operations should be permitted if it's loaded into memory. PFR makes it readable. PFW makes it writable. And PFX means it's code that should be allowed to execute on the CPU. Oh. Section header table. Data. Wait, this stuff is like some of it. Feels like it like there's .text. This is also in assembly. BSS and .data. Cool. The section header table is a series of entries containing information about sections. Oh, so all this stuff we're doing in assembly, it's like in the section header table.
Me says 07.
It's close to the CPU. Yeah, where the kernel is and where files execute. It's pretty cool. This section information is like a map, charting the data inside the ELF file. It makes it easy for programs like debuggers to understand the intended uses of different portions of the data. Oh, text, BSS data. What the SHSTRTAB? Section header table is like a map for binary data. For example, the program header table can specify a large swath of data to be loaded into memory together. That single PT load block might contain both code and global variables. There's no reason those have to be specified separately to run the program. The CPU just starts at the entry point and steps forward, assessing data when and where the program requests it.
Corrupt Converter says make an OS in assembly that only runs Tetris.
Sounds like a bad idea. Yeah, I'm just really trying to get more of like a gist, see what I can understand. There's gonna be things I don't, but that's fine.
Corrupt Converter says Tetris OS.
Nothing of the. Well, you did start in the middle. I did start from the beginning of this, so it's a little bit easier for me, just because it started like from the beginning, and also I talked a lot with Corrupt about like assembly and how the memory works, so I have a little bit
Of me
of an
says same
idea.
Casper Caper 17.
But yeah, even though I don't understand like literally everything. Well, a lot of it I don't, but I'm just trying to understand like some of the basic ideas of how the computer works with the programs you want to execute. And then this is the part kind of where assembly starts to like fit in, which is like close. Assembly is just very close to the CPU, so like, not a lot of like abstraction. I'm like, hey, there's no reason those have to be specified separately to run the program. Start for testing when. However, software like a debugger for analyzing the program needs to know exactly where each section starts and ends. Otherwise, it might try to
Casper
decode some
Caper
text.
17 says my knowledge of memory is fairly limited. I know most in the context of a specific language, with like garbage collection.
Yeah, so the basics is like the computer. Yeah, the computer has like works with memory. Like it has these registers that can hold certain. They're like boxes on the CPU, and that's how it
Of me says Salt has an expert on hand Casper Caper 17.
That's how it like does stuff to the data. Like it works. It has these little boxes on the actual chip where it brings in the data, and then it works with the RAM and stores those things in like a line
Corrupt
that it
Converter
can jump
says who's
around
the
on.
expert.
The expert's corrupt. But yeah.
Corrupt Converter says no.
Think particular above my table code variables. Yeah. Needs to know each variable starts and ends. Otherwise, I might try to decode some text that says hello as code. And since
Corrupt
that isn't
Converter
valid
says I
code,
literally suck at coding.
that's great. And since that isn't valid code, explode. This is definitely what the computer does when something bad is done. This information is stored in the section header table. Oh yeah, we're reading about the section header table, program header table. Section header table, program header table. Huh. Forward. While it's usually included, the section header table is actually optional. ELF files can run perfectly well with the section header table completely removed, and developers who want to hide what their code does will sometimes intentionally strip or mangle the section header table from their ELF binaries to make them harder to decode. Oh, I see. So it's like, this is like, I think this is like the assembly code almost, and then the program header table was like, it's like the actual binary that the assembly code was turned into type thing. So by like removing this, it makes it like a pain for people to like figure out what's going on. That's what I'm imagining. Wait, no, data is all the binaries data. Never mind. But this one is probably like the basic, you know, like the text and stuff for the like assembly. That's what I imagine.
Corrupt Converter says section header table sounds like a bunch of labels or connections and stuff.
It does. Like on a larger scale or like, yeah. What's what?
Corrupt Converter says like tells you what's what.
Alphas. Okay. Each section has a name, a type, and some flags. Let's specify how it's intended
Corrupt
to be
converter
used and
says
decode
I'm
it.
gonna sleep.
Okay, good night, Corrupt. Yep, need to get up early. Well, you know, need enough sleep for tomorrow. And learning to swim is probably a good idea. Like, it'll probably be really helpful and make it easier for you if you can, if you have the time. Name, type. I was intended to be using the code it.
Corrupt converter says doing what?
Doing what? Standard names usually start with a dot by convention. The most common sections are type, name, some flags. .text. Machine code to be loaded into memory and executed on the CPU.
Corrupt converter says learning didn't hear next word.
Oh, I just said it. If you have the time and are able to learn how to swim before you join the military, it probably be make it easier. Like, that was a good idea. Machine code to be loaded into memory and executed on the CPU. Yeah.
Corrupt converter says oh yeah that true yet.
Yeah, that wouldn't be
Corrupt
good, but you're not going
converter
to
says
drown
so I
and
don't
die.
drown and die in basic.
That won't happen, though. It just might be, like, annoying to have to learn extra things when you're already flooded with lots of new information.
Casper Caper 17 says everyone needs to know how to swim.
It is mandatory to get a swimming diploma? No way. So interesting. That's smart, though, that you do that over there. SHT prog bits. Type with the SHF exec
Corrupt converter says sleep.
Inster flag. Execute. To mark it as executable. Yep, good night. Corrupt.
Casper Caper 17 says I suppose Arizona has less water, even though there is more land.
Execute instruction. I couldn't recognize that. Oh wow, not execute instruction. Oh nice, thank you, Carl. And the SHF allocation flag, which means it's loaded into memory for execution. Don't get confused by the name. It's still just binary machine code. I always found it somewhat strange that it's called .text, despite not being readable text. Oh yeah, so this is the... Yeah. Wait, .text is where you would write most of the code, so I guess it just looks... It's compiled into binary at this point. Like, it shows the binaries in there. .data. Initialize data hard-coded and executable to be loaded into the memory. For example, a global variable containing some text might go in this section. If you write low-level code, this is the section where statics go, so this is relevant to assembly. This also has the type SHT prog bits, which just means the section contains information for the program. Program bits, not prog. Its flags are SHF allocate and SHF write to mark it as writable memory. Hey, row data. It's on here too. BSS. I mentioned earlier that it's common to have some allocated memory that starts out zeroed. It would be a waste to include a bunch of empty bytes in the L file, so a special segment type called BSS is used. It's helpful to know about BSS segments during debugging, so there's also a section header table entry that specifies the length of the memory to be allocated. It's of type SHT, no bits, and is flagged SHF, allocate SHF right. Row data. This is like .data, except it's read-only. In a very basic C program that runs printf hello world, the string hello world would be in a read-only data section, while the actual printing code would be in a .text section. SHST RTAB. No, string. Oh, wait, maybe not string. I don't know. This is a fun implementation detail. The names of sections themselves, like .text and .shstr tab, aren't included directly in the section header table. Instead, each entry contains an offset to a location in the ELF file that contains its name. This way, each entry in the section header table can be the same size, making them easier to parse. Oh. An offset to the name is a fixed size number.
Casper Caper17 says I am going to head off as well.
Yeah, good luck in your lecture. Thank you, thank you. But this is more just about...
Casper Caper17 says good luck with assembly.
This is more about just the CPU in general. With some, it just ends up crossing in to assembly. This particular thing I'm reading isn't strictly about assembly. Yeah.
Casper Caper17 says oh I see, I see.
It's called CPU LAN. Injecting the section header table. Instead, each entry contains an offset. Oh yeah. Whereas including the name in the table would use a variable size string. Easier to parse an offset to the name's fixed size number. Yeah, let's see. All of this name data is stored in its own section called SHSTRTAB of type SHTSTRTAB. Data. The program and section header table entries all point to blocks of data within the ELF file. Whether to load them into memory or specify where program code is, or just to name sections. All of these different pieces of data are contained in the data section of the ELF file. Oh. Program header entry. PT. I already got what this too far. Oh. Program header table. Interpreter. Program header entry. Load. Section header entry. Read only data. Etc. I think I'll we'll switch into some kind of academy. composite numbers. Oh. I forgot that the non-prime numbers were called composite. Serious? Let's see. cool. command. Wow.
Command make space hello. Common mistake. You do not, where now I'm going to do that second command make for me, and I'm going to go back to my terminal window, where now I'm going to do that second command make space hello. Common mistake. You do not say make hello.c and for me. Cross my fingers, line 5, like that. Make any type window. Where now I'm going to do that second command make space hello. Common mistake. You do not say make hello.c because you already made that file. You say make hello, which is the name of the program that in this case I do want to create. And make is smart. It's going to look in my folder, and if it sees a file called hello.c, it's going to convert that source code to machine code and save the results in a simpler, shorter named file just called hello, like an icon on your desktop. Now, hopefully nothing will happen, and that is a good thing, quite paradoxical. Desktop. Results in a simpler, shorter named file, just source code, look in my folder, and if it sees a file called hello.c, it's going to convert that source code to machine code and save the results in a simpler, shorter named file just called hello, like an icon on your desktop. Now, hopefully nothing will happen, and that is a good thing, quite paradoxically. If you do anything wrong when programming, odds are you're going to see one or many more lines of error sort of yelling at you that you made a mistake. Seeing nothing happen is actually a good sign. So the last command, to run my code, recall our 3 steps here. We ran code to create the file, make to compile the file from source code to machine code. So lastly, is /hello. So this now is the equivalent of my like double clicking on a Mac or PC or single tapping on a phone. Enter. So close. All right, it's pretty good. I got the HELLO, comma, space world, but there's something a little stupid about my output. What might rub some of you aesthetically the wrong way? Yeah. Yeah, so the $sign looks like I was like, hello world, $sign in my output, but no, that's just kind of a remnant of my prompt starting with a $sign. And this is a little nitpicky, but this just doesn't feel right, doesn't look right. It's not quite correct. So how can I go about this? Is a little, it's just kind of a remnant of my prompt starting with a $sign. And this is a little nitpicky, but this just doesn't feel right, doesn't look right. It's not quite correct. So how can I go about fixing this? Well, here's where, at least initially, it's going to take some introduction to like just new syntax in C to fix this. Like the simplest instinct might be to do this. Well, let me just hit enter like that. But this should soon, if not already, rub you the wrong way, because in general we're going to see that programming in C and in Python and other languages tends to be line-based. Like you should really start and finish your thought on one line. So if you're in the habit of hitting enter like this and sort of finishing your thought on the next line, generally programming languages don't like that. So this is in fact not going to do what we expect, and just to show you as much, I'm going to do this. Let me go back to my terminal window here. I'm going to rerun make hello as much like this, and sort of, you should really start and finish your thought on one line. So if you're in the habit of hitting enter like this and sort of finishing your thought on the next line, generally programming languages don't like that. So this is in fact not going to do what we expect, and just to show you as much, I'm going to do this. Let me go back to my terminal window here. I'm going to rerun make hello after making that change, enter, and then
Oh, wow.
There we have it, like the first of our erroneous outputs. And it's yelling at me, it's missing a terminating character, and there's some red in here, some green, drawing my attention to it. Sometimes these error messages will be straightforward. Sometimes you're gonna like rack your brain a bit to figure them out. But for now, I've kind of spoiled that obviously enter is not the right solution. So let me clear my terminal window just to hide that error. Let me delete this, and let me propose now that I add this incantation here. So \n, it turns out, is going to be the sort of magical way of ensuring that you actually get a new line at the end of your output. So let me go ahead now and rerun make hello, because I've changed my code. I need to now recompile the source code to new machine code, /hello, and now there is the canonical hello world program that I hoped to write in the first place. So for now, don't worry about the include, don't worry about the standard IO, don't worry about int or main or void or the curly braces. Focus primarily on line 5 here, and over the course of today and next week, we'll start to tease apart the other characters that for now you should take at face value. Questions, though, on any of the steps we've just done? Yeah? Sure, why is the \n inside of the quotation marks, if you will? So shorter answer is like, that's just the where it needs to be, because inside of the quotes is the input that you want printf to output to the screen. So if you want printf, this function, to output a new line, it must be included in the quoted text that you give it. Exactly. \n is a special pattern that printf no means, okay, I should move the cursor to the next line. Good question. Other questions on any of these steps? Yeah? A good question. So what if you actually want to print \n? Things get a little tricky there. Let me go ahead and propose that we do this. So it turns out, and this is often the case in programming, when you want a literal character to appear, you actually put another \ in front of it, but this is not going to be something we do often, but there is in fact a solution to that. But let me propose that beyond that now, we sort of compare it against what we've actually done. So here is the first Scratch program we wrote with the green flag there. Here, recall, is the mental model that I proposed we have for almost everything we do, whereby functions are just an implementation, say in code, of algorithms, step-by-step instructions for solving problems. The inputs to functions, recall from last week, are called arguments, or in some context, parameters. And sometimes functions can have side effects. Like last time with Scratch, there was the speech bubble that magically appeared next to the cat's mouth as a sort of side effect of using the say block. So just like this, then, we had the white oval as input. The say block was the function last week, and then we had this here side effect. Well, how do we compare these things? Like next to the cat had the white oval as input. The say block was the function last week, and then we had this here side effect. Well, how do we compare these things left to right? Well, here's the say block at left. Let's compare now to the C code at right. Notice a couple of things to sort of adapt from Scratch to C. Print is almost the name of the function. It is technically printf, for reasons we'll eventually see. Notice the parentheses in C are kind of evocative of the oval in Scratch, and that's probably why MIT chose an oval, because a lot of languages
flowchart shapes, yeah.
Use parentheses in this way. You still write hello world, just as we did last week in Scratch, in this way. You still write hello world, just as we did last week in Scratch, but per our demo thus far, you do need the double quotes, and double quotes, not single quotes, double quotes on the left and right, and in order to get that new line, you need the \n, and one more thing is missing. Yeah. The semicolon to finish your thought. So all of these sort of stupid things now that honestly you will forget initially if you've never programmed before, but you'll soon, within days, within weeks, develop the muscle memory where all of that stuff just jumps off the page right at you. All right, so these escapes, this \n is generally known, just so you know, as an escape sequence. And so \n allows us to specify a character that might otherwise be hard to type. But let's tease apart some of the other things atop that function already. So include standard io.h. It turns out that in C, a lot of the functionality that comes with the language is tucked away in separate files. So if you want to use certain functions, you have to tell the compiler, hey, I want to do some standard input and output. Like, I want to print some things on the screen. And that's because, for now, you can think of printf as living in this file, standardIO.h. That's a bit of a white lie for now, but in standardIO.h is essentially a declaration for printf that will teach the compiler how to print things to the screen. So hash in
work says in some languages I was told you also need to do \r to make sure when it moves to the next line it moves to the beginning.
Ah. That's interesting.
Me says return.
Oh, you mean that sometimes it's /r instead of /n?
include here simply tells the compiler before it does anything else, essentially go ahead and find on the local hard drive. Simply tells the compiler before it does anything else, essentially go ahead and find on the local hard drive a file called standardIO.h and kind of copy paste it there. So I know now about printf. So this thing, this .h file, is what we'll technically call a header file. And if you've ever heard this word, especially if you have programmed before, it represents essentially what we'll start calling a library. So a library in the world of programming is just code that someone else wrote that you can use. So if you have is what we're now about printf. So this thing, this .h file, is what we'll technically call a
the .h stands for header.
Header file. And if you've ever heard this word, especially if you have programmed before, it represents essentially what we'll start calling a library. So a library in the world of programming is just code that someone else wrote that you can use. It's usually free and open source, which means you can literally see the code that someone else wrote, or sometimes you pay for it. Sometimes it's closed source, which maybe Microsoft wrote it. They won't show you the code, but they will let you use the zeros and ones. So libraries are super useful because honestly, even I don't really know how printf works. I've taken for granted for 25 years that if I use printf, stuff prints on the screen. But someone smarter than me had to actually write.
Me says studio lights.
Yeah, he's sweating a lot. It's true. Poor guy.
The code in C that figures out how to get the H, the E, the L, how to actually write the code in C that figures out how to get the H, the E, the L, O, and so forth onto the Mac screen, the prints on the screen. Printf works. I've taken for granted for 25 years that if I use printf, stuff prints on the screen. But someone smarter than me had to actually write the code in C that figures out how to get the H, the E, the L, O, and so forth onto the Mac screen, the PC screen, the phone screen, or somewhere else. So libraries allow us to sort of stand on each other's shoulders, and so that someone else can do the hard work, and we can now.
Someone's on their phone, like texting or something.
Now solve problems that are more interesting to us, not the basic commodity.
Oh, I guess that's a computer.
Stuff that everyone solve problems that are more interesting to us, not the basic commodity stuff that everyone might want in their code. So again, library is code that someone else wrote.
I think she's taking notes on Google Doc.
Header file in C is just a file ending in .h that gives you access to the same. And so, for instance, if you want to learn more about these, there are what are called, in the world of programming, manual pages. And these are textual files, like a documentation of sorts, via which you can just learn how a function works and how you can use its inputs or arguments. The reality is they're written for folks who aren't in CS50. They're written for folks who aren't just learning how to program. They're written for and by folks who have been programming for years. And so frankly, they're a little hard to understand. And so CS50 has its own version thereof at this URL.
Oh, nice. They have their own. It's just like you. Ah. Oh, nice. They have quite a bit. This is cool.
manual.cs50.io, where you'll see not only the official documentation for C, the language, but also staff-written simplifications in layperson's terms, what all of the various popular functions are, what their inputs and what their outputs are. So for instance, under standardio.h, you can actually go to that website. You can go to a URL like this, where standardio.h is in there, and you can actually see the documentation therefore. So let me go ahead and do this. I'm going to go ahead in my browser here. I'm going to go to manual.cs50.io. And let me go ahead here and select those functions that are frequently used in CS50. And under standardio.h, you'll see a bunch of functions, only one of which we've even discussed, called printf. I'm going to click on printf there, and you'll see an interface that at first glance might be a little overwhelming, but it's going to start to look more and more familiar. So first of all, you'll see that if you want to use printf, under synopsis, you need to include this header file. Like you literally copy and paste that line into your own code. You'll also see this, which for now is a bit arcane, but this is kind of a hint as to what the function is going to look like, but more on that. But this is kind of a hint as to what the function is going to look like, but more on that soon. But more importantly, you can read a description about it. And because these descriptions, when you're in less comfortable mode, are written by me and the course's teaching fellows, teaching assistants, and course assistants, you'll find them to be much more in layperson's terms. And so long story short, rely on this site when you want to learn how to use some function and also what other functions exist. In fact, if I go back to the main page here, you'll see that there are all of these functions, like are frequently used in CS50, and there's hundreds more that come with C. But learning a programming language is not about learning all of those, but rather just getting a sense of where you find answers to questions when you do want to try something new. But what is important to know for CS50 today is that we have our own header file called cs50.h, which has functions that we have written just to make life easier in the first few weeks of the class. These are training wheels that will eventually take off, but it turns out in C, especially if you've programmed before, training wheels that we have written just to make life easier in the first few weeks of the class. These are training wheels that will eventually take off, but it turns out in C, especially if you've programmed before, it's actually really hard and annoying just to get input from users, to get them to type a word or a number or something else. Like C does not make this easy, in part because it's one of the earliest languages that wasn't zeros and ones. So you have to do a lot of the heavy lifting yourself. But we'll put on these training wheels today and for a few weeks so that we can focus really on the intellectually interesting.
So far away from him that he has to speed walk over there.
Yeah, he walks back and forth a lot in this. Where do you get this CS50.h thing? Wait, maybe it's an FAQ. Oh, do you have to get it from GitHub? Maybe it's this. I hope he kind of explains how to, like, use this. Because in this course, they use, like, a cloud version of Visual Studio Code. You need, like, an account and stuff.
Ideas of C and programming with really on the intellectually we'll put on these training wheels today and for a few weeks so that we can focus really on the intellectually interesting ideas of C and programming without getting bogged down in certain weeds that we will come back to before long. So for instance, CS50's own documentation is there at that URL, but within the library are these functions. A function called getString to get a string of text. String is a synonym for just text in a programming language, so getString will prompt the human for a string of text. GetInt is shorthand for getInteger if you want to get a number from the user. GetFloat is a little more arcane. Get a floating point number, like a real number with a decimal point in it, and ... There are others as well. So this is to say, within CS50, we've got some user-friendly functions via which we can actually get some input. And let's go ahead and use one of these, for instance, getString. Because recall that last week, our second program in Scratch was this one here, where we didn't just say hello world, we said hello David, or hello Carter, hello Yulia, whoever it was typing their name in. But to do that, we needed this ask block in Scratch, and then we use the say block, and then we use the join block to kind of make all of this work. So let's translate this program now into C, because it's a little more interesting and representative of the kind of, let's translate say block, and then we use the join block to kind of make all of this work. So let's translate this program now into C, because it's a little more interesting and representative of the kind of code we'll start to write. But we need a slightly different mental model. Still have a function here, which is the implementation in code of an algorithm. We still have some inputs called arguments, but previously I said that the say block and in turn printf have side effects, which is just something visually, typically, that happens on the screen. Other functions actually have what we called last week return values. And this is kind of analogous to a function maybe doing something for you, writing down the answer on a slip of paper, and then handing you, the programmer, the slip of paper to do whatever you want with it without just broadcasting it to the world with like a speech bubble on the screen. So a return value is germane for a program like this because recall when we used the ask block and I typed in my name, where did my name end up initially? It didn't go on the screen yet. Where did it end up? In an answer puzzle piece. And that special oval puzzle piece I claimed at the time represents a return value. So the sort of metaphorical piece of paper that the answer is written down on so that I can then use it later. So that's what we want to get to now in C, a return value that I can then do anything I want, whether it's printed to the screen, change it in some way, save it in a database, or anything else. So here, for instance, is what we did with Scratch. The input to the say block, or the ask block, was what's your name, quote unquote. The function, of course, is the ask function, and the return value was answer. If we now consider how we might translate this to C, It's going to look a little weird at first, but it's going to follow a pattern today, next week, the week after, anytime we do code like this. So getString, I claim, is going to be the most analogous function in C to the ask block. And to be clear, this is a CS50 specific thing, training wheels of sorts, but we'll show you in a few weeks what this function is doing and how you cannot use it moving forward once you're comfortable with the language itself. Notice I put parentheses left and right as sort of a placeholder for user input, and that user input is going to be, what's your name? But I can't just put what's your name in parentheses. What do I minimally need to add in there too? Yeah, so the double quotes left and right, so let me go ahead and add those in. I left a space here, not for a new line. I could move the cursor to the next line, but I minimally at least want to move the cursor at least one space over, just so it looks pretty, so that when I'm prompted for my name, there's a space between the question and my answer, but it could also be \n. That's just an aesthetic choice on my part. But what do I do with the answer that comes back from getString? This is where the text is going to look different today. In C, you start to use an equal sign from left to right, respectively. And on the left, you put the name of the variable in which you want to store that return value. So a return value is kind of a conceptual thing. You can do with it what you want, and if I want to store it longer term in a variable, like x or y or z in math class, I can just give it a name here, x or y or z, or more reasonably, answer, or any other English word. No spaces, generally lowercase, same heuristics as before, but this means now, ask the user what's their name, whatever they type in, go ahead and store it from right to left in this variable called answer. But C's not done with us yet. If you've learned Python or certain other languages, you'd kind of be done writing code at this point. In C, though, you additionally have to tell the compiler what type of variable you want to use. So if it's a string of text, you say string. If it's an integer, a number, you say int, as we might have seen before. So it's a little more pedantic. It's more annoying, frankly, the more onus on you and me, the programmers, but this just helps the compiler know how to store it in the computer's memory. And I'm so close to being done with this line of code, but what's missing? So semicolon.
Why can he make that weird shape with his hand?
Mark my words, if you've never programmed before, sometime this week, this semester, you will forget a semicolon. You will raise your hand, you'll get frustrated because you can't understand why your code's not working. You will run into stupid issues like that, but do take faith that they are stupid issues. It doesn't mean it's not clicking for you or you're not a programmer. It just takes time to see these things if it's a new language to you. So there now is my semicolon. All right, let's go ahead then and do something with that return value using the second of the big puzzle pieces in Scratch. So when I wanted to say hello, comma, David, or whatever the human's name is, I kind of stacked my puzzle pieces like this. This is actually similar to Python and maybe some other languages some of you have learned, but C is a little bit different, and the closest analog to this Scratch solution is going to look like this. I still use printf, because printf is the equivalent of say. Inside of my parentheses, I'm going to go ahead and say, weirdly, hello, comma, %s. So there's no real analog in C of join. Instead, there's a way to specially format text using printf, hence the F in printf. And what you do in printf is you type whatever English word or human words that you want. You then use %s as a placeholder. If you want a string of text to be added to your own text, you literally write %s. And let me anticipate a question from the crowd. How do you print out %s? There's a solution to that too, if you literally ever want to print out %s. But it's text. Please type whatever. Join parentheses, I'm going to go ahead and say, weirdly, hello, comma, %s. So there's no real analog in C of join. Instead, there's a way to specially format text using printf, hence the F in printf. And what you do in printf is you type whatever English word or human words that you want. You then use %s as a placeholder. If you want a string of text to be added to your own text, you literally write %s. And let me anticipate a question from the crowd. How do you print out %s? There's a solution to that too, if you literally ever want to print out %s. But it's deliberately a weird choice of characters so that the probability that we ever need to type this ourselves is just low, that no one really worries too much about it. All right, but that's not quite enough. In addition to saying hello, comma, space, placeholder, %s, and just for vocabulary's sake, that's a format code, again, format being the F in printf, I still need my double quotes around the whole thing. In this case, to match my previous program, I am going to go ahead and add the \n to move the cursor to the next line. And now I've left a crazy amount of room here, but that's deliberate. Does anyone have an instinct for what I'm probably going to want to add after the quotes, but still inside of the parentheses? So answer itself. I need to somehow tell printf with a second input, otherwise known as an argument, what I want to substitute for that %s. And so I put a comma and then the name of the variable that I want printf to figure out how to plug in here. So honestly, it's a little annoying, and this is kind of a dated approach. Like newer, more modern languages, like we'll see later in the course, Python and JavaScript actually have much more user-friendly ways of doing it. But once you wrap your mind around the heuristics, the rules here, it's just formatting a string by plugging in whatever you want into this format string, so to speak. And the comma here is important. This signifies that it takes one input at left and a second input at right. But notice this comma. There's technically 2 commas, but I'm not claiming that this function takes 3 inputs. Why? This comma I'm pointing out doesn't mean the same.
It's because that comma is part of the quotation marks and is then part of like the string.
Exactly. This comma that I'm pointing to is part of the quotation marks and therefore part of my string of English text. So this is just English grammar. This is sort of C syntax. And again, these are the sort of annoying little details that we're using the same symbol for different things, but context matters. So just stare at your code, look carefully left to right, and generally the answer will pop out. No pun intended. OK, questions now on this syntax before we actually write it and run it. Yeah? Why is the \n not after the answer? So the way functions work, including printf, is that you pass to them one argument.
Also, why is this screen so, like, low on the ground? Why does he have to, like, crouch to show things?
Inside of the parentheses. And then if you have a second argument, pass to answer. So the way functions work, including printf, is that you pass to them one argument inside of the parentheses. And then if you have a second argument, you put it after this comma here. But the way printf works is that its first argument is always a string that you want to be formatted for you. So anything you want printed on the screen has to go in those quotes. And you can perhaps extrapolate from this. If I actually wanted to say multiple things in this sentence, so hello, maybe first name, last name, I could actually do hello.
Yeah.
Comma, %s, space, %s. If I had 2 variables, one called first name, %s, space, %s. If I had 2 variables, one called first name, one called last name. But then I would need another comma for a third input to the function. And so it's very general purpose in that sense. Questions? Yeah? OK, so can you abstract away the format string itself, hello, comma, answer? Short answer, yes, but not nearly as easily in C as you can in other languages. So that's why we're keeping it simple for now. But you're going to love something like Python or JavaScript, where a lot of this complexity goes away. But you'll see also in Python and JavaScript and other languages, they still are inspired by syntax like this. So just understanding it now will be useful for multiple languages down the line. All right, so let's actually do something with this code rather than just talk about what it might be doing for us. Let me go over to, for instance, VS Code again. And I'm going to go ahead now and remove this middle line of printf. I'm still in my same file called hello.c. I'm going to clear my terminal window just to eliminate distraction. And to do that, I can literally type clear. But this is just for aesthetic's sake. That's not functionally that useful. Or you can hit Control-L to achieve the same on your keyboard. But I'm going to go back to line 5 here, where I previously just said hello, comma, world. And I'm going to do this instead. I'm going to give myself a variable called string. Do this, but I'm not to eliminate distraction. And to do that, I can literally type clear. But this is just for aesthetic's sake. That's not functionally that useful. Or you can hit Control-L to achieve the same on your keyboard. But I'm going to go back to line 5 here, where I previously just said hello, comma, world. And I'm going to do this instead. I'm going to give myself a variable called string. I'm going to give myself a variable called answer, the type of which is string. I'm going to set it equal to whatever the return value is of getString, asking an English question, what's your name, question mark, with just a single space, just to move the cursor over, followed by a semicolon. Then I'm going to go ahead and say printf, quote unquote, hello, comma, placeholder, \n, close quote, comma, and then what goes here again? This is where answer goes. And then I just need to semicolon on the right of that. But I think now that I'm done. But let me point out a couple of details. This got very colorful, very pretty quickly, and it's not like the black and white code I had on the screen a moment ago. This is because what programs like VS Code do for us is it pretty prints, or rather it syntax highlights our code for us. So syntax highlighting means just add some colors to the code so that different ideas pop out. So you'll notice, for instance, that printf here, getString here are in purple because they represent functions, just like the say block. Here, what's your name, quote unquote, in VS Code is a light blue instead of white, but it's still going to be consistent if I use strings of text elsewhere as well. So I didn't type anything special. This isn't like Microsoft Word or Google Docs where I'm highlighting and changing colors of things. This is all happening automatically, but it's just Unicode text. It's just being interpreted automatically and having these colors applied so that things pop out more usefully visually. Now, I've unfortunately made a mistake, but I'm going to deliberately induce this one, because you too will probably make this mistake. I'm going to go ahead and run make hello again, because I've changed my code, so I have to regenerate the machine code from the new source code. But unfortunately, when I hit enter now, my God, the errors don't even fit on the screen. So let me make this bigger. I'm going to click the little caret symbol here just to make my terminal bigger for just a moment, and you'll see that there's like more lines of errors than there are of code that I actually wrote, often which is written pretty arcanely, again, for programmers who've been writing code for 10, 20 years, but there are some details that pop out. So notice the problem is definitely with hello.c, so great, it is my fault. This syntax here means that line 5 is the problem, and this next 5 means character 5. So you can literally like triangulate your bug, your mistake, by going to line 5 and then over 5, and it's somewhere in that area. Specifically, the area is use of undeclared identifier string. Did you mean standard in? I don't think I did. Like, I do want string, and then there's some other complexity here. But what's important here is not the specifics of this error, but really the implication that it doesn't recognize the word string or getString. Now, why might this be? Yeah? Exactly. Because we are using getString, which I claimed is a CS50 thing that we'll use for a few weeks, C does not know about it out of the box, so to speak. I have to teach the compiler that getString exists, just like I taught the compiler that printf exists, by including the appropriate header file. And in this case, quite simply, it's called include cs50.h. That now teaches the compiler, oh, someone else wrote this function already, getString, and with it this type of variable called string. So now if I go back to my terminal window and rerun the exact same command, make hello, maybe crossing my fingers, now nothing in fact goes wrong, because the compiler's been brought up to speed with all of the functionality it needs. And now if I do /hello, enter, there it is. What's my name? And notice the cursor's one space over, just because I thought that looked prettier than having the cursor right next to the question mark. DAVID as my input, and enter, and hello, comma, David. All right, questions on any of this code thus far? Questions? Any of the code? No? All right, so let's introduce some other functionality into the mix. It turns out that there are other types of data, other types of variables in the world, not just strings, but indeed, per before, we have things called integers, int for short, floating point values, float for short, and a few others as well. So rather than only focus on string, let's get a little more interesting with numbers here and see what we can do with something like integers, again, int for short, by taking a look at not getString as before, but now how about getInt? And for this, I'm going to give us a few other tools in our toolkit. Those format codes to which I alluded earlier, like %s, fortunately are pretty straightforward. And here is a list of most of the popular format codes that you might ever care about with printf. In particular, we saw %s for string, and you can perhaps guess which one we're going to use for integers. Yeah, so %i is what we're going to use for integers. And this is the kind of thing that you can consult in the manual pages or a slide like this. There's only a few of them that you might frequently use. But let's go ahead and use integers in a more interesting context, not just using functions, but let's revisit this idea of conditionals. And conditionals in Scratch were like these proverbial using functions used. You can consult in the manual pages or a slide like this. There's only a few of them that you might frequently use. But let's go ahead and use integers in a more interesting context, not just using functions, but let's revisit this idea of conditionals. And conditionals in Scratch were like these proverbial forks in the road. Like, do you want to do this thing or this other thing? It's a way of making decisions in a program, which is going to be super useful and pretty much omnipresent in any problems that we try to solve. So let me give you a few more building blocks in C by doing the side-by-side comparison again. So here in Scratch is how we might say if two variables, x and y, are one is less than the other, then go ahead and say, quote unquote, x is less than y. So kind of a stupid program, but just to show you the basic syntax for Scratch, this is how you would ask the question. If x is less than y, then say this. So say is the function, if is the conditional, and the green thing here we called what? What do we call it? Yeah. A Boolean, or a Boolean expression, which is just a fancy way of saying a question whose answer is true or false, yes or no, 1 or 0, however you want to think about it. In C, the code's going to look like this. So it'll take a little bit of muscle memory to develop, but you're going to say if. Then in parentheses, you're going to say x less than y, assuming x and y are variables. You're then going to use these curly braces. And then if you want to say, quote unquote, x is less than y, in C, what function should we use here? Presumably. So printf. So printf, quote unquote, x is less than y. So it's a bit of a mouthful, but again, notice the pattern. Name of the function is printf. In the parentheses, left and right, is the argument to printf, which is, quote unquote, x is less than y. And again, just for aesthetics, to move the cursor to the next line, which you don't have to worry about in Scratch, because everything's in speech bubbles, we're adding a \n as well. So notice that these curly braces, as they're called, much like the orange puzzle piece here, are kind of like hugging the code like this. And I'll note that technically speaking in C, if you only have one line of code inside of your conditional, you can actually omit the curly braces altogether and the code will still work. If you have one single line of code, why? Just saves people some keystrokes. If you have 2 lines, 3 lines, or more in there, you need the curly braces. But I'll always draw it with the curly braces in class so it resembles Scratch as closely as possible. As an aside too, some of you who have programmed before, you might be cringing now because like you really like your curly brace to be over here instead of here. Like that too is a stylistic choice, and we'll talk too about this in the class. Aesthetically, stylistically, there's certain decisions we can make, but generally in a class, in a company, you as a student or an employee would simply standardize on one set of rules, so to speak. So we'll use these rules for formatting our code in class consistently. All right, any questions on this snippet of C code? All right, a couple of others then. So here is how in Scratch we might have a two-way fork in the road. If x is less than y, say x is less than y, else say x is not less than y. In C, it's going to look pretty much the same, but notice I'm adding an else keyword here with another set of curly braces. I'm going to have a couple of more printfs, but in C, even though it's clearly keyboard-based, it's just text, no more puzzle pieces, it's kind of the same shape, so to speak, and it's definitely the same idea, so it's following a pattern. What about a three-way fork in the road? If x is less than y, then say x is less than y. Else, if x is greater than y, say x is greater than y. Else, if x equals y, then say x is equal to y. Well, you can probably see where this is going on the right-hand side. It looks almost the same. In fact, if I add in the printfs, it's really almost the same, at least logically, but there is at least one curiosity. Seemingly a typo, but it's not this time. Yeah. Yeah. The double equal signs does not match Scratch, but it's not, in fact, a bug or a mistake in C. Anyone have an intuition for why I did use 2 equal signs instead of 1 here? Yeah. Well, otherwise it would be mistaken for a variable, specifically assignment of a variable. So recall that in previous code, when we used the getString function, we used an equal sign to assign from right to left the value of a variable. And that's a reasonable decision. Equal kind of means that the two should ultimately be equal, even though you think about it from going right to left. Unfortunately, the authors of C kind of painted themselves into a corner, and presumably decades ago when they realized, oh shoot, we've already used a single equal sign, how do we represent equality of two values? The answer they came up with was, all right, we'll just use 2 instead. And thus was born this decision. Is it the best one? Who knows? Crazy enough, in other languages like JavaScript, you have not just 1, but 2, but also 3 equal signs in a row to solve yet another problem. So reasonable people will disagree as to how good or bad these decisions are, but in C, this is what you must do. But there's a bad design decision here too. It's still correct, the code, left and right, but I bet I could critique the quality of the design of both the Scratch code and the C code for reasons what? Okay, no, really good intuition. Do we have to ask this third question, else if x equals y? So short answer, no, logically, right? Just based on arithmetic, either x is less than y, or x is greater than y, or what's the only other possible answer? They must be equal logically. So technically, you're just kind of wasting the computer's time by asking this question because it already knows at that point the answer, and you're wasting your time as the programmer bothering to type out more code or more puzzle pieces than you need because logically one stems from the other. So I can tighten this up, get rid of the else if, just use an else, and I can do the same thing over here in C, thereby avoiding the double equal sign altogether, but not because it's wrong, but because you're wasting time, because now you're potentially asking only 2 questions, 2 Boolean expressions, instead of 50% more by asking a total of 3 questions at most. Other questions then on this kind of code, logically or otherwise. All right, so if we have these puzzle pieces, so to speak, at our disposal, how can we go about actually using these? Well, suppose that we actually want to do something with values. Let's introduce variables in C as well. Well, this kind of code, logically or otherwise. On this kind of code, logically or otherwise. All right, so if we have these puzzle pieces, so to speak.
What did he whisper to himself?
All right, so if we have logically or otherwise. All right, so if we have these puzzle pieces,
Something or otherwise.
So to speak, at our disposal, how can we go about actually using these? Well, suppose that we actually want to do something with values. Let's introduce variables in C as well. We saw an example using a string a moment ago, but what about with something like integers? Well, you might not have used this in Scratch, but here's the orange puzzle piece in Scratch via which you can create a variable called counter to count things, and you can set it equal to some value like 0. Now you can perhaps guess where we're going with this. If I want in C a variable called counter, and I want to set it equal to 0, I use a single equal sign, because logically you read it from right to left, or technically it's executed from right to left. But that's not enough in C. What's missing from the screen? I need a what? So we need a data type, and if it's going to be an integer, indeed I'm going to use int, and now the other mistake I keep making is so a semicolon at the end of the line. So it's a little more verbose than some languages, but if you read it left to right, this is how you tell C to give you a variable called counter of type int and initialize it to a value of 0. That's all. All right, how about in Scratch if you want to change that variable by 1, by adding 1 to it? In Scratch, it's super simple. You just change it by 1 or even -1 if you want to go up or down respectively. In C, turns out you have a few different ways to do this. And this looks like it's not mathematically possible, but that's because equals is assignment, recall. So this line of code is not saying that counter equals counter plus 1, because that's just not possible using typical numbers, but this means take counter's value, add 1 to it, and assign it back to the counter variable. So it's like incrementing counter in this way. But this is such a common thing in C and in programming to increase or decrease the values of variables. There's a more succinct syntax. This is identical. And it might take a little, practice to get used to it, but it just saves you some keystrokes. But it similarly adds 1 or whatever number you use there. And this is such a common operation in C especially that there's an even tighter way of executing the same idea. And you can literally just say counter plus plus, and then semicolon in this case. All three are exactly the same. All three are perfectly correct. But you'll learn over time that typing less on the screen is probably going to save you some time. Meanwhile, if we wanted to do the opposite and do something like -1 in Scratch, we could similarly do minus minus in C, or we could do, minus minus in C here at right. All right, so just some additional building blocks translating from Scratch to C. Why don't we go ahead and try using this perhaps in the following way. Let me go ahead and go back to VS Code, and let me propose that we do something like this. In VS Code, I'm going to go ahead and clear my terminal window. I'm going to close hello.c by just clicking the X. I'm going to go ahead and create a new file called compare.c, because the purpose in life of this program is going to be to compare integers on the screen. This time, I'm not going to mess up. I'm going to preemptively include cs50.h. I'm going to preemptively include standardIO.h. And here, too, is a very common mistake in learning C. It is not studio.h. So when you email us asking why studio.h is not working, that's because that is not the word. It is standardIO.h, meaning standard input and output, stuff involving the screen and the keyboard. Then I'm going to go ahead and, just as before, int main void. But we'll come back to that eventually as to what it means. And now inside of main, which is just where the main part of my program goes, again, you can think of this as being analogous to when green flag clicked. This just kicks everything off. I'm going to go ahead and do two things. I'm going to go ahead and get an integer called x, and I'm going to prompt the user for that int and just say something like, what's x, question mark, space. Then I'm going to do int y equals get int, quote unquote, what's y, question mark, space. And then let's just do something simple, like if x is less than y, then go ahead and print out, quote unquote, x is less than y, backslash n, close quote, semicolon. So it's not a very deep program. It's just going to do what most any human brain could do pretty quickly, but it's at least demonstrating how we might use now something like a conditional in code. So let me go ahead and let me compile this code for the first time, make compare, enter. Nothing bad happens, which is good. /compare is how I run the program. And just to tease this apart, dot, as we'll soon see, essentially means that the file is in your current folder. So dot means in your current folder, and we'll eventually see that dot means your parent folder, like the one that contains wherever I am on my computer's hard drive. All right, /compare, what's x? 1 on my computer's dot means your parent folder, like the one that contains wherever I am on my computer's hard drive. All right, /compare, what's x? 1. 2 for y, and hopefully it should say that x is less than y. So pretty straightforward, proof by example, and hopefully this would work in other cases too. But if I flip that around and I rerun it, /compare, and I do 2 and 1, nothing's going to happen. But you would expect that because there's only one Boolean expression deciding whether or not I should actually type this out. So what's going on? Well, if this helps you, you might find it useful to think about the logic of any program, be it in Scratch or C, as kind of a flow chart of sorts. And we'll put up a few of these over time, just in case you're a particularly visual thinker. And this represents what it is I just did. So here in this picture is where the program starts conceptually. And anytime you see a diamond, think of that as a Boolean expression, a question that's being asked. And the question being asked is x less than y? That has two possible answers, true or false, yes or no, respectively. So let me propose per the arrow that if the answer is true, then print out, per this rectangle, x is less than y, just quote unquote, and then stop. That's it for the program. But logically, if x is not less than y, that is, that question's answer is false, we'll just skip right to the end and stop. So this is a control flow diagram. It's just a pictorial way that you could write on a piece of paper that just represents what it is the program is doing. And this gets a little more interesting if now we do something else with the code. For instance, instead of just concluding that it's less than x, less than one or the other, let's go back to the code here. Let me clear my terminal window, and let me add an else. So else, go ahead and print out x, I don't think I want to say this, greater than y. It's not quite right. What would be reasonable to say here? Yeah, subtle, but x is not less than y, because it could be equal. We don't know if we're only checking two scenarios here. So if I recompile this, make compare, /compare. Now if I do 1, 2, I still get the same answer. If I rerun /compare 2, 1, I now get the opposite answer. It's not as good as might be ideal. It'd be nice to know if it's equal to or greater than, but at least that's all of the code that we have here. And just to now paint a picture, if I go back to my control flow diagram, my flow chart here, this is what it looked like before logically. Now that I've added in a second branch, so to speak, now if the answer is false, I first print out x is not less than y, and then I stop the program. So same idea, but the decision tree, if you will, if you've taken ect10 or the like, is getting a little bit bigger now, conceptually. All right, what if we do something more than this? Let's actually have that third condition. Let me go back into my code here. I'm going to hide the terminal window just to make room for more code. And I'm going to say else if x is greater than y, then go ahead and say not x is not less than y, but rather x is greater than y. And then down here, I'll do an else if x equals y. Then I can go ahead and say printf x is equal to y \n, close quote. All right, so now if I run it, let me open my terminal window again. Let me rerun make compare. Let me rerun /compare. 1 and 2 are the same. Let me rerun it. 2 and 1 are the same. Let me rerun it a third time. 1 and 1 are now in fact equal. So this works correctly, but why did I make a point of using these else ifs? Put another way, couldn't I just make my life a little simpler and just say if this, then that, if this, then that, if this, then that? Just ask all three questions, keep the code simple, don't bother with these else's. Would this work for me? Yeah. Yeah, so it saves a little bit of time because in this case, just like in English, this is like asking 3 separate questions. And it's not harnessing any information from previous questions in order to decide whether you should bother asking that other question. In other words, if x is less than y, and you already figured that out because it's 1 and 2 respectively, you're going to print this. Why would you waste time asking this question when it's not going to be true? Why would you waste time asking this question when it's not going to be true? And so the point I wanted to make here, which is that if we visualize that particular design, what the flow chart looks like is actually this. And let me zoom in at the top. If you ask the question, is x less than y? Well, you're going to go ahead and say x less than y. Then if you go down to the next question, you're still going to ask, is x greater than y? And then below that, you're still going to ask, is x equal to y? So no matter what x and y are, you're asking 1, 2, 3 questions all of the time. But if we actually go in and do what we did the first time, where if I go back to my code and I undo this edit and add back the else ifs, and now let me go back to the flow chart, which I claim is bad because it's 1, 2, 3 questions, 1 or 2 of which might not be necessary. Now if I visualize what I just did, the flow chart gets a little more complicated looking, but it's going to be better designed, more efficient. Why? Well, because if I start at the top here, I ask one question, is x less than y? If the answer is true, okay, I say x less than y, and then boom, I sort of cheat and go all the way to the end of the program and stop, having asked only one question. If, though, x is not less than y, okay, fine, I'll ask you a second question. But if the answer is true, boom, I print out x is greater than y, and then I stop. And only in a perverse case where x actually equals y, which I'm going to claim is very unlikely or infrequent, only then am I going to ask 1, 2, 3 questions to figure out whether or not to print something at all. So this is what we mean by distinguishing between correctness of code, because it's still correct, but this version is better designed, because hopefully you're going to go down this branch or this branch rather than the longest one frequently. Any questions now about this code or this visualization thereof? Yeah. A perfect segue. Why did I bother, though, even asking this question? Don't need to, because when I hit this button, hopefully I have the right slide in place, this would be even better than that design. So thank you for teeing that up. This is the same picture. It sort of got bigger because there's fewer nodes, fewer shapes in the picture. Notice that if x less than y, boom, we say as much and we stop. If x is not less than y, but it's greater than y, boom, we stop. Or if it's not greater than, we immediately conclude x indeed is equal to y, and again we stop. So this picture is about as efficient and as well designed as we can make our logic. That's about as good as we can solve this problem. So if I go back to my code now to make my C code match that, the only thing I need to do is stop wasting the computer's time. Don't ask that third question. Just logically, mathematically conclude that, of course, it's going to be equal at that point in the story. All right, any other questions on that? Sorry, a little louder? Really good question. What if I put in something that's not a number? So here too is where the CS50 library and the implementation of getInt will be your friend. So for instance, if I run /compare and I want to compare cats and dogs, I could type in cats, enter. It's just going to prompt me again and again. It's not going to let me type in dogs either. It's going to force me to give it an integer. C does not do that by default. And in fact, as we'll soon see over the course of CS50, C is actually a very dangerous language at the end of the day because it just trusts that the human is doing what it wants. And as such, a lot of today's software that is hacked in some ways, if it's using C or another language called C++, are actually very vulnerable to certain types of hacking, whereas other languages that we'll get to in the class are less so, for reasons like this. All right, so besides this, let's consider just one other data type, how about? So besides strings, besides chars, there's some others on this list here. Sorry, besides strings, besides integers, there's this other data type here in C known as a char for a single character. So here, let me just tease this apart. A string is indeed a string of text. It is 0 or more characters together. A char is always precisely one character. Not all languages bother distinguishing between like a single character and a string of characters, but in C, a string is typically multiple characters, but technically it could be 0. Coincidentally, it could be 1, but it's capable of being more. But a char is literally, as the word implies, a single character. All right, given that, notice that in the CS50 library, besides getString, besides getInt, we also have getChar, so another handy function for just getting a single character from the user. Now, why would it be useful to get a single character from the user? Well, what if you're just doing something that you and I do pretty frequently when you install new software or fill out some form? You agree to some form of terms and conditions. So in fact, let me go back over to VS Code here, and let me propose that I create a new program called agree.c. So something akin to asking for the user's agreement. So in VS Code, I'm going to type code, agree.c, and I'm going to do some quick boilerplate. So include cs50.h, include standard.io.h, int main void, and then inside of main, which is like the green flag clicked, I'm going to do this. Go ahead and get a character from the user and ask them something simple like, do you agree? Expecting a yes/no response. But at the beginning of this line, I need to put the return value somewhere. So I'm going to put it in a variable called C. And in programming, if you're just getting a single value, it's OK sometimes to use X and Y or C. When you're using larger programs, you'll benefit from using actual words like answer, like we did from the get-go. But C has to be a specific type, so I'm going to literally say char, and then I'm going to finish my thought with a semicolon. And here's now how I could check if the user agrees or not. I could do something like this. If the value of C equals quote unquote lowercase y, then go ahead and print out agreed \n. Else, if the variable C has a value equal to lowercase n, let's go ahead and print out, say, not agreed, as though I'm agreeing or not to some terms and conditions. But notice, these are not typos. What did I do ever so subtly different from last time I used text? Yeah. Single quotes instead of double quotes. So here's the heuristic. When using strings, which are generally multiple characters, have to use double quotes. When using a single character, you should use single quotes around the single character. So let me go ahead now and make agree. Nothing went wrong, which is good. /agree, enter, and let me go ahead and type in Y for yes. It seems to work. Let me run it again. /agree, N for no, and it seems to work. And just if I type in something random like question mark, I don't know, it doesn't crash, it just ignores me because I only had 2 Boolean expressions there. But notice that it's actually a little buggy, arguably. Let me run it again, /agree, enter. Notice that it's actually a little buggy, arguably. Let me run it again, /agree, enter. How about capital Y, because like my caps lock is down. Okay, it just ignores me. Let me do it again, /agree, capital N, because my caps lock is down. Okay, it just ignores me. But this should make sense because I'm literally checking for lowercase. So how could I fix this? How could I fix this without just changing lowercase to uppercase? Because that would then break it in the other direction. Yeah. Yeah, let's just add another branch here, so to speak. So if variable c equals capital Y, then I can go ahead here and say printf agreed. And then let me close my terminal to make more room. Otherwise down here, else if c equals capital N, let's go ahead and again say printf not agreed. And I claim that this would actually now work. It's 4-way fork in the road, but I'm at least checking for lowercase, uppercase for Y and N respectively. I claim that this is correct, but this too, even if you've never programmed before, should start today to rub you the wrong way. Like, we can do better. This isn't the best design. Why might that be? Yeah. Ah, clever. So could we change the variable c to just be forced to uppercase or maybe forced to lowercase, no matter what the human types? We just do that ourselves. So that way we can just simplify this again to 2 possible scenarios. I love that, but we haven't seen any functions yet in C that would let me change things to uppercase or lowercase. So we'll get there, but a good instinct and correct. Other thoughts? So we could use or in some sense, like a logical or. Like, what I don't like about this, to be clear, is that it's repeating itself. And like, there's this principle in programming and in life in general, like, don't repeat yourself unnecessarily. And by that I mean I literally have the same line 10 as 14. I have the same line 18 as 22. And if anything, I literally wasted twice as much time as I needed to. Put another way, per our discussion of Scratch, what if I go in and just change something like, I want to be more excited, like agreed? Well, I might forget to change it in the other place, and let's just claim for today's purposes that that looks stupid, it's a bug, because I want them to be consistent. So don't invite situations where you might change something in one place but not another, just only write it in one place total. So I like this idea of or-ing things together, so let me go ahead and delete what I just did. And just to be clear too, while this is on the screen, when you highlight code in VS Code, based on how we've configured it, these dots just show you how much I've indented. Because in C, stylistically, the convention is generally to indent 4 spaces and maybe 4 more spaces, so those dots just help you count without having to manually eyeball things yourself. But let me delete those lines, let me delete these lines, and this is count without having to manually, generally to indent 4 spaces and maybe 4 more spaces, so those dots just help you count without having to manually eyeball things yourself. But let me delete those lines, let me delete these lines, and this is going to look a little weird, but the way you can or 2 thoughts together, so to speak, like or them together, is you don't say or, but you use 2 vertical bars, which syntactically means the English word or, and you can just ask the other question, if C equals quote unquote capital Y. And then down here I can say or C equals capital N. So it adds a little more code to each of those lines, but it doesn't add redundancy because I've not duplicated my printf. I've not added more curly braces unnecessarily. Now, as an aside, there's the opposite of or, logically, is the word and. Just so you've seen it, I could do this. Ampersand, ampersand in C is how you express that the thing on the left must be true and the thing on the right must be true. But why would this make no sense in this context of line 8? Yeah, like, at least to my knowledge, like, a character can't be both lowercase and uppercase. That just makes no logical sense. So indeed, or is what we want in this case. Other questions? A good question. Via cs50.h, is there a way to compare strings? Short answer, no, but C is going to give us that capability. And in fact, next week, among the things we'll do is actually compare strings. And if you've programmed before, you'll see in C that it actually doesn't work the way ability. And in fact, a good question. Via cs50.h, is there a way to compare strings? Short answer, no, but C is going to give us that capability. And in fact, next week, among the things we'll do is actually compare strings. And if you've programmed before, you'll see in C that it actually doesn't work the way that you might expect, but that's a problem too that we will solve. But that transcends CS50. That's a question for C. Other questions on this kind of logic? Just to make this real, then, like, anytime you like click one of those EULAs or like terms and conditions on a form in a piece of software, like, odds are there is code as simple as this underneath the hood. Maybe it's graphical, maybe it's checking for you clicking this button or maybe hitting the enter key, but underneath the hood is presumably some kind of conditional checking for those kinds of outputs. All right, how about another building block from last time, which will now translate to C, namely loops, things that happen again and again, and these two are everywhere in code. So in Scratch, here's how we might meow 3 times. Super simple. In C, it's going to look a little weird, but you will get used to this over time if you've never programmed before. Looks like a mouthful. Okay, but let's tease it apart line by line, and you'll see that you won't have that reaction frequently because it's all going to start to look very similar to itself. But what are we doing here? In C, you don't have the luxury of these cute and fun puzzle pieces that just kind of do the work for you, repeat 3 times. In fact, in C, and programming in general, sometimes the work is on us to actually figure out, okay, how can I use functions, variables, conditionals, and loops, and implement some idea like repetition, like looping? And in C, here's how this might work. How can I conditionals in C and cute and fun? It's all going to start to look very similar to itself. But what are we doing here? Line by line, and you'll see that you won't have that reaction frequently because it's all going to start to look very similar to itself. But what are we doing here? In C, you don't have the luxury of these cute and fun puzzle pieces that just kind of do the work for you, repeat 3 times. In fact, in C, and programming in general, sometimes the work is on us to actually figure out, okay, how can I use functions, variables, conditionals, and loops, and implement some idea like repetition, like looping? And in C, here's how this might work. How can I go about doing something like printing meow 3 times? Well, I know about variables now. We're about to see loops, and I've seen how I can update variables by plussing or minusing like some value to them. Let's combine those ideas. So first, I'm doing what with this highlighted line in English? If a friend cared to ask you, like, what is this line of code doing later today, what would you say? Good. It's creating a variable called counter and setting it equal to 3. I'll use slightly new jargon. I'm defining a variable would be the term of art, called counter and setting it equal to 3. So I'll use my hand to represent the counter. And that's all a variable is. It's like storage in some case that I'm representing information using my hand in this case or the computer's memory here. Now what happens when using a loop in C? There's different types of loops, one of which is called a for loop, one of which is called a while loop, spoiler. A while loop works like this.
I'm switch back to do 4 of these. The word control flow?
Of me says I've never heard of control flow before.
Yeah, control flow just means if, and it's just conditional statements and loops. It's an umbrella term. Whoever followed, thank you. Oh, I guess I see what they're doing. Chill. Oh, damn. Wait. Let's... Oh wait, I was lining these up wrong in my head. Oh my god. It's like... See? Wait. Nothing to... 5, 2... Oh my god. Ten. Four. 2. It's always throwing me off when there's 3 places and 2 places on the other. Is this always 1? Oh my god. 10, 2, 3, 4. Oh. Oh, that ended up wrong. Let's keep watching this.
Inside of parentheses is a Boolean expression, just like inside of a conditional that asks a question. But this time, the question is going to determine, do you keep going through the loop again and again and again? So it's not a one-time thing, potentially. It is checked again and again and again to decide when it is time to stop looping, to stop cycling. All right, so it's asking this question first, is counter greater than 0? Okay, obviously, the answer is true, because I'm still holding up 3 fingers. So what happens? C goes inside of the curly braces, per the indentation, and executes printf of meow, which prints out a meow on the screen. The next line of code executes, which recall is the same as just subtracting 1 from counter. So I think I take down 1 finger, so I'm left with 2. And what happens next? Well, this you just kind of have to memorize. Once you get to the end of the inside of a loop, you go back to the beginning of a loop here and ask the same question, the same Boolean expression. So is 2 greater than 0? Okay, obviously so you go into it, you print a meow, you go into it and decrement counter further by 1. So now my hand is holding up 1. Now we wrap back around to the Boolean expression, is 1 greater than 0? Obviously, we print out a third meow. We then decrement counter again, and my hand goes to 0. We go back around once more. Is 0 greater than 0? No, and now the program just terminates, or if there were more code here, it would just jump outside of the curly braces and keep going lower on the screen. So that's all that's happening, and so this is what MIT has the luxury of doing with pictures, but at MIT, someone probably essentially wrote code that looks like this to give us the illusion, the abstraction of this. So what we're learning today is sort of how they invented these puzzle pieces by just using lower level plumbing, if you will, like this here. Yeah? A really good question. What would happen if you created the variable inside of the curly braces? Short answer, it just wouldn't work in C, because if I were to try, with my slide here, for instance, to move this line of code here down inside of this, for instance, now the very top line is trying to use counter before it even exists. So C is very literal. It reads top to bottom, left to right, and if it hasn't seen you define or create a variable yet, you're going to get some scary error message on the screen instead. All right. Other questions on this here code? No? All right, so if we want to then maybe tighten this up a bit, let me propose that we could do this instead. So besides this version of the code, let me just do something more canonical, more conventional. So you're totally fine with using a variable like counter. It's what Scratch uses by default. It's very verbose. It does what it says. Frankly, once you get comfy with programming, like most typical programmers, whenever they have a single integer in a program whose sole purpose in life is to count, they'll just use I for integer, just like I used C for character. When you have larger programs, you don't want to start using A and B and C and D and E and A used typical using a variable like counter. It's what this version of the code. Let me just do something more canonical. Then maybe tighten this up a bit. Let me propose that we could do this instead. So besides this version of the code, let me just do something more canonical, more conventional. So you're totally fine with using a variable like counter. It's what Scratch uses by default. It's very verbose. It does what it says. Frankly, once you get comfy with programming, like most typical programmers, whenever they have a single integer in a program whose sole purpose in life is to count, they'll just use I for integer, just like I used C for character. When you have larger programs, you don't want to start using A and B and C and D and E and F and so forth for your variables because nothing's going to make any sense. But when you're doing something super simple like counting with an integer, using a short named variable is totally stylistically reasonable. But I can tighten this up further. Not just renaming counter to I. What else can I do, if you recall? Over here? Yeah, sure. Okay, for loop, yes, that was my spoiler. But while in the while loop, I can tighten this up slightly more. Over here? Yeah, instead of I equals I minus 1, I can actually tighten this up this way. And we didn't see the minus before, but it's the same idea. I minus equals 1, or even more succinctly, I minus minus. So when you get comfortable with programming, any of these approaches are correct. This would be more conventional at this point. So if you want to write code like most other people write code, adopt ultimately these kinds of conventions. All right, so that just does the exact same thing, though. But let's now put this into practice. Let me go back to VS Code here. Let me go ahead and clear my terminal and close agree.c from before. And let me go ahead and create a file called meow. So code meow.c. And let me do this the sort of wrong way. Let me include standard.io.h at the top, int main void thereafter. Inside of there, let me do printf meow. And then you know what? I don't want to keep typing that. Let me just go ahead and copy paste 2 more times. So I claim this is correct. Make meow, /meow, done. I've got code that prints meow 3 times. But this again should already rub you the wrong way. Why? Yeah. Because what? Because I have duplication. I mean, I literally copied and pasted, and that's kind of a good rule of thumb. If you, in the future, start finding yourself copying and pasting code within the same program, you're probably doing something wrong. There's a better way to design it, even if it's correct. So this is clearly a candidate for a loop, so let me go ahead and actually do that. Let me just go ahead and remove all of this duplication. Let me give myself a variable called I, set it equal to 3. Let me go ahead and give myself a while loop and check that I is greater than 0. Inside of this loop, let me print out just meow once, but I'll reuse that code again and again, because here I'm going to do I minus minus. So that's the exact same code, the type version of it that we saw a moment ago. Let me go ahead and make meow again. /meow, and it still works. Why is this version better? Because if you want the cat to meow 5 times, you change it in one place. If you want to make the cat a dog, you change the meow to a woof in one place, albeit changing the file name eventually, but changing it in one place, not worrying about changing it again and again and again. But there are other ways to do this. For instance, let me propose that, and actually, let's see, let me propose that instead of just doing it this way, just to be clear, yeah, let's go ahead and propose that instead of doing this, we can actually count in different directions, right? I'm kind of forcing this idea of starting at 3, going down to 0, but when normal humans in this room, if you ever count something, you probably do 1, 2, 3, and done. Like that's how we would count in the real world. Well, we can do that too here, code-wise. We could initialize I to 1. We could check that I is less than or equal to 3. And we've not seen this syntax before, but there's no easy way on a typical keyboard to type a less than or equal sign like in a math book. So we use 2 characters, a less than sign and then an equal sign, back to back, and that means less than or equal to. And this is the same idea so long as I plus I inside of it, because that'll start at 1. Then 2, but it won't stop then. It will go up to until I is equal to 3. Once I becomes 4, then that Boolean expression isn't going to be true, so it stops after 3 meows total. But there's another way too, and this is probably the most conventional and the way you should do it, even though it's just as correct. In CS, if you've seen already last week, we almost always start counting from 0. Why? Like just because, so we're not wasting a pattern of bits. So generally, when you start writing code that counts, you should, quote unquote, almost always start at 0, count up to, but not through the total you care about, so you don't get 1 extra by accident. And so this would be the most conventional way of doing what we just described. But they're all correct. You can make an argument by accident, start at 0, even though it's just as meows total. But there's another way too, and this is probably the most conventional and the way you should do it, even though it's just as correct. In CS, if you've seen already last week, we almost always start counting from 0. Why? Like just because, so we're not wasting a pattern of bits. So generally, when you start writing code that counts, you should, quote unquote, almost always start at 0, count up to, but not through the total you care about, so you don't get 1 extra by accident. And so this would be the most conventional way of doing what we just described. But they're all correct. You can make an argument that all of them are equally good. This is what most people, quote unquote, would do. Okay, other questions on this here syntax or logic? No? All right, how about, we got some cookies on the horizon, but before we get there, let's meow a few more times if we may. So how about doing a little bit differently versus the while loop? And I think we heard it over here. Turns out there's another type of loop altogether. So this one here. And this one, if you can believe it, is probably even more conventional than the other way. And this is going to be thematic in programming. Like there's rarely one way, one right way to do things. You're going to have bunches of different tools in your toolkit, and your code might look different from someone else's because each of you tends to reach for a different tool in that toolkit. And here's another tool, and as you proposed earlier, a for loop. A for loop is just another way of achieving the exact same idea using slightly different syntax, and it's appealing, frankly, in general, because it's a little more succinct. It just saves some keystrokes, even though you have to memorize the order in which it works. This code is identical to this code here. functionally, but aesthetically, of course, it looks different. How does it work? In a for loop, notice that in the parentheses is not a single simple Boolean expression. There are three things. One, before a semicolon is a place to initialize a variable, to do your counting typically. Second is the Boolean expression. So it's still there, it's just surrounded on the left and the right by two other things. Lastly is the update. What do you want to do at the end of every loop through this block of code? So you can probably imagine where we're going with this. How does this work? The first thing that happens is that a variable called I is defined and initialized to the value of 0. That happens once and only once. Then we check the condition. Is 0 less than 3? Obviously, yes. So now we don't do the plus plus yet. We go into the loop, and this is where the for loop's a little confusing at first. We print out meow. Then what happens? There's no more lines, so we go back to the for loop, and we increment I at that point. So now I is 1. Then we check the condition. I is less than 3, yes, because 1 is less than 3. We go back into the loop and print meow. Now we go back to the plus plus, so I is now 2. We check the condition. 2 is less than 3, obviously, so we go back into the loop and print meow. Then we do the increment. I is now 3. Is 3 less than 3? No, so we exit the loop, and we're done, or we keep going down here if there's more code. But how many times did I say meow? Like 1, 2, 3 total, when my hand was 0, 1, and 2. Questions on this alternative syntax? It takes some getting used to, but most people would write loops using a for loop, I would say. Yes, if you really want to be cool and save syntax, yes, it is correct and common to eliminate the curly braces if you only have one line of code therein. We in class will always put the curly braces there because this is the kind of thing where if you get forgetful, you go in later and add a second line, like darn it, like you forgot the curly braces, things will not work as expected. So in general, use the curly braces, but you do not have to strictly. Other questions on 6? Yes? Can it be used without what? Oh, could you do it without the condition? Yes, there are very fancy things you can do that we won't focus on today, but yes, if you want to get rid of the condition, you could get rid of this here, and that would actually make the loop go forever, which may be a good thing if it's like a clock that you want to tick forever, but often not a good thing in code. Good question, though. All right, so beyond that, let's just go ahead and put this into context just in case it helps you to think about this. This is just another flowchart, if you're more of a visual thinker, that represents what it is this loop is now doing. Previously, all of our arrows went from top to bottom and stopped, but now there's an arrow going back up and around because of this loop, this cycle. So when we start this program, we set I equal to 0. We then check, is I less than 3? Obviously it is, so we print meow, we increment I, and then we go back to that same condition. We check the condition, we print meow, I plus plus, go back. Go back. Now, if I equals 3, 3 is not less than 3, so the answer is false, and we stop. So again, it's just another way of thinking about how the code in Scratch, how the code in C might alternatively work in each of these contexts. But there's this one other puzzle piece in Scratch, recall, that's not the repeat block, which is for finite numbers of repetitions, but forever. And in C, there is a way to do this, but it's a little weird looking. There's no forever keyword, but you can use the while loop, or as you inferred, you can actually use the for loop without a condition in the middle. So here, I can actually say this. If I want to do something forever, I want to make sure that the answer to my question, the Boolean expression, is always true, always true, always true. The easiest way to achieve that goal is just like literally write true there, because true is true no matter what, and it's a trick for making the loop forever go around and around, as you might if you want the cat to live forever and meow incessantly, or if it is a clock that you want to tick forever or the like. So here, for instance, is how we might have a cat meow endlessly using this so-called for loop instead. But recall that in Scratch, we also had this ability to create some of our own puzzle pieces, and this too is something that we're going to be able to do here in C. And let me propose that we do exactly that by introducing the C analog of this. So here, for instance, is, in Scratch, our definition of a function called meow, whose sole purpose in life was to just play the sound meow until it's done. This is going to look a little weird at first, but you'll notice some similarities with main. So recall this thing I keep typing with main, int main void, int main void. That's just the when green flag clicked equivalent for today. But if you want to create your own puzzle piece or your own function in C, you, for now, literally do this. You say void, the name of the function you want to create, and then void in parentheses. And technically what this means is that this function has no return value. It doesn't hand you anything back like getString or getInt. And the void in parentheses means it takes no inputs. It only meows. You don't have to tell it how to meow. It's just going to meow. So no arguments, so to speak. This literally just prints out meow. But what this does for me is it abstracts away the idea of meowing. I don't need to know how to use printf or that you're using printf to make the cat meow. I now have a function in life called meow. Because in Scratch, recall, I used it like this. When the green flag is to make the cat meow, I now have a function in life called meow. Because in Scratch, recall, I used it like this. When the green flag is clicked, I could repeat 3 times this new custom puzzle piece. But in C, I could now do this. In my main program, I can use a for loop, just like we saw a moment ago, copy-pasted from earlier, but now I can call my own C function called meow. And let me go ahead now and do this. If I go over to my C code here, back in VS Code, let me go ahead and delete everything inside main. Let me go ahead and do for int I equals 0, I is less than 3, I plus plus. Inside of my curly braces, let me go ahead and say meow, but I now need this meow function to exist, because if I do make meow again, notice, error, implicit declaration of function meow is invalid in C99, the 1999 version of C. What does that mean? Well, it doesn't know what the meow function is. And the meow function is not in cs50.h, it's not in standard io.h. What is that? Implicit declaration of function meow is invalid in C99, the 1999 version of C. What does that mean? Well, it doesn't know what declaration of function meow is invalid in C99, the 1999 version of C. What does that mean? Well, it doesn't know what the meow function is. And the meow function is not in cs50.h, it's not in standard io.h. I have to create it. So let me type out or really copy paste what I had on the screen a moment ago. Void meow meow, void meow void, printf, quote unquote meow, close quote, semicolon. But here too, let me scooch this down a bit so you can see all the code at once. Let me now do make meow, and unfortunately, I still have an error. If I scroll up, still on line 7 of meow.c, my compiler thinks that meow is invalid, that it does not exist. This too is a common mistake, and as simple as this code might be in spirit, where did I screw up? Yeah, in the middle. Yeah, I need to define the function before I use it. So again, C is going to take you literally. If you try to call meow on line 7, you better not define it on line 11. You better define it higher up. So the simplest fix is going to be just to do this. Let me clear my terminal. Let me highlight and just delete the meow function. And let me just paste it up here. And this will actually solve the problem. Make meow now works. And if I do /meow, that too works.
Interesting. If I remember, I don't think C# has this problem. I think it doesn't matter where stuff goes.
Works. But this isn't really the best solution, because if your solution is constantly, oh, we'll just put it up there, put it up there, put it up there, I bet we could contrive a situation where one function needs to be above the other, but it needs to be above the other, and it's just not going to work in general. And more importantly, it just situation where one really the best solution, because if your solution is constantly, oh, we'll just put it up there, put it up there, put it up there, I bet we could contrive a situation where one function needs to be above the other, but it needs to be above the other, and it's just not going to work in general. And more importantly, it just pushes main lower and lower and lower in your file. But the whole point of your main function is like that's the entry point. Like that is what happens when the green flag is clicked. And so just in terms of user conventions, it's just useful for main to always be at the top of a file, because then you can find it fast. Your friends can, your TFs can find it quickly if it's at the top. So the other solution here would be to leave meow at the bottom and leave main at the top, but this is the only time, if I may, that copy paste is okay. What I've highlighted here in line 11 is what's called the function's prototype. It is enough information to give you the return type, the name of the function, and the return value, and any arguments. And so if you just copy paste that one line and end it with a semicolon up there, that's enough of a hint to the compiler that, okay, it doesn't exist yet, but it will, and it will look like that. That's the only time it's okay to copy paste the very first line of a function you've written to the top of the file with a semicolon so that you can make Clang, so you can make the compiler happy. So if I do make meow now, still no errors, /meow, and it now works. But let me add one final feature, coming back to Scratch here, and then it's time for a snack. So here, recall, was sort of the last fancy thing we did in Scratch, where we created not only our own custom puzzle piece, but it took an input, so that we didn't need to keep using the loop ourselves. We could just let the meow function be told how many times you want the cat to meow. So in C, we don't have to make that many changes, except this. We change the prototype to take an argument inside of parentheses. And this is the syntax for that. If you want your own function in C, to take one or more arguments, you give the argument a name, n, or whatever you want to call it, but you have to tell C what the type of that input is. So it's an int n, so it knows it's a number. And then you can just use n in your program. So instead of hard coding, typing manually the number 3, I'm just using n here. So this is equivalent to what I did with Scratch by just dragging and dropping the n variable there. And then meow will get printed that many times. If I want to then use this, notice this is the last version of the cat that we did last week. You just say meow this many times. So in C, this is where now the code gets very succinct, because all the main part of the program does is meow 3 times. So this, again, is an abstraction. I don't need to know, care, or remember how meow is implemented. I just need to know what its return value, its name, and any arguments thereto are. So if I make this change, I think we can get the cat to meow any number of times. Let me go back over to my C code here. Let me go back into the file and change void here to be int n, where n just means number. I could use I, but n tends to be a quantity instead of a counter. I then, inside of this function, am going to do a for loop. For int I gets 0, I less than n instead of 3, I plus plus, and inside of here I'll paste that meow again. I need to change my prototype to be identical, so another copy paste or just manually edit it. But now notice what's cool about main is that now I can meow maybe 3 times, make meow, enter, / meow. Okay, or if I really want to be cool, I can change this to like 30,000 times. Go back here, make meow, increase the size of my terminal window for a dramatic pre-break flourish. And there are that was a fast cat. There are 30,000 meows. I think now let's go ahead and take, that's a lot, a 10-minute break. We'll see you in 10. Cookies are now served outside. All right, so we are back. And I realize this has been a lot.
Well, I'm jealous they get cookies. Oh wait, I thought it was addition. 18. Six. $70.964. What? This is not fair. 8.0. How is this? What is this? I mean, this is wrong, but wait. I'm kind of curious. What is this? This also doesn't match up with this one. There's so many mistakes with this. Okay, I'm saving this problem so that I don't get marked wrong again. That was annoying. Now I'm actually kind of worried that these are all going to be wrong. Hello.
Dush50 says hi there, just joined.
Does it seriously think it's this one again? Or is this just a sample problem? Like, what is this? Are you serious? Okay, so all these are wrong. That's great.
N_sweep says LMAO cursed.
This is cursed. Like, absolutely cursed. I can't believe I have to write this. I'm gonna have to write this all over again. So it looks like always question number 2 is wrong. So just remember that. This has to be a bug. This is so dumb.
N_sweep says at Tush50, hey guys, hey guys, hey guys. N_sweep says how's it going aside from a broken course?
Fine, other than this, honestly. Oh, it's you, Sweep. This is broken. I didn't know it was you. This is broken. I hate this more than broken. This sucks. This is not fair. But it looks like question number... Wait, what? What? 5 minus 1. What's the solution to this one? Look at this. They're all okay. This is sad. So I wanted to, okay, I'm not gonna be able to finish this then. I wanted to 100% all of Khan Academy. Some programmer screwed up.
N_sweep says LMAO they're all busted.
They literally like mixed up, I don't know, someone did an off by one error on like the solutions and the problems, and now they're all mixed up, and you can't finish this freaking level. So now I can't 100% Khan Academy, and I'm sad now. My goal. My dreams! My dreams! I hate this. Okay, well.
N_sweep says LUL probably.
Yeah, well. No, I'm sad now. Well, I'm gonna have to skip this one. But it's not my fault. I tried. I literally tried. I should do this. Now that I should report one more time and say, like, some programmer made an off by one error and all the answers are wrong. I'm sad. Can I copy this? I'm gonna just copy the answer. Maybe I'll come back to this particular lesson like a year from now and pray they fixed it. Aw, I'm sad. I can't believe they did this. Maybe I shouldn't write that so I don't get my account banned. I don't think that would happen, but still. Well, I was wrong, man. I thought it was just, like, one problem. Like, I thought it was always on the second problem. And then the answer would always be 6.597, but apparently not. Everything's just mixed up. So. Nah. This is making me, like, question everything, too. I'm like, I think this is... Well, actually... Oh, wait, yeah. Like, how would it not be this? I mean... Wait, does this copy? Yes. I really use a ... to show my discontent. All the answers. What are these even called? Units or something? I think I did one that was... Okay, well... I'll never be able to crown it. Unless I just, like... I mean, I technically could if I just copy all the wrong answers. I think. That's dumb. I don't want to do that. You know what? Why am I doing this anyway? Right now that you're here. Maybe I'll try some Python, because I haven't really done any problems. I was just like watching videos, watching more of the CS50 course. I'm sad you had to see that curse. The curse math, though. Yeah, not that. Whatever that was.
N_sweep says haha yeah let's do some coding.
Or maybe I should just use that as like motivation. Like, hey, if you mess up your code, you'll end up getting a horrible result like that. And I don't want to be like that. I don't want to be that kind of coder. I want to make things that function the way they're supposed to function. That's, I know. Okay, so.
N_sweep says that's the spirit.
Card games. A list is immutable. Actually, you said this yesterday to me. That lists are mutable. I think you're the one who said that. Or someone said it. Collection of items in sequence. Like most collections, see the built-ins. Typical dictionary. Set. Oh. Set. I've never heard of this one. Set. What the heck is a frozen set object whose elements are taken from iterable? Like lists, but they can only have
N_sweep says sets are like
no
lists,
duplicates.
but they can only have unique values inside.
That's kind of cool. I can see how that's useful. Honestly, that's cool. Thank you. And that saves me from having to read through the document. Why can't the documentation just say that? Like, why does it have to be so complicated? It's like frozen set and all this stuff, like, that I don't need right now.
N_sweep says think of it like a set in mathematics.
Oh, okay. Oh, but speaking of, like, a set in mathematics, like, it's pretty confusing why, like, all numbers are just sets of they're like sets of nothing. Like, how does that even make sense? I don't even understand, but anyway. No reference to any multiple data types. Math is weird. Like, you can't just say something is nothing.
N_sweep says LMAO math is weird.
Why is that allowed? I don't... Combo class? Oh, yeah, I'm collecting as many YouTube channels as possible.
May I recommend a YouTube channel called Combo Class?
Here, I'll copy that so I can subscribe later. I'm kind of curious. It's pretty cool that you, like, teach other people Python. Do you usually just, like, help people with what they're working on? Or do you ever give assignments to the people you work with? Math videos and vibe is so good. Oh, hell yeah. Actually, I might even...
Good.
That sounds familiar. I think I might already be subscribed. Let me check. Because it does sound... Combo class. I'm not.
N_sweep says I give assignments to people who don't have project ideas of their own.
I see. That's cool. What the heck? Okay, I subscribed. There are like a trillion different like math and like coding channels all over YouTube. I swear every day I subscribe to like 10 more because there's just so many of them. And then new ones keep popping up every week. It's kind of insane. But I'm happy the algorithm keeps recommending like so many different things to me.
N_sweep says someone who has never coded before, we do a magic 8-ball game, a Mad Libs, rock, paper, scissors, and then a deck of cards, the game of war.
Oh, that's so cool. Maybe I'll copy and paste those things and like try to do something like that sometime. For ideas. No real decisions. Oh yeah, it can kind of just play itself.
N_sweep says war is a good game because there are no real decisions, so you can program the whole thing.
I'm just disappointed that you don't force all your students in the first week to code their own LLM from scratch and train it. That too.
Of me says I'll watch the combo class videos on clocks and fixing multiplication tables.
Let's see.
N_sweep says the intention of that project is to teach classes, i.e. a card class and a deck class, to play the game.
Card class? Ah! Card class and a deck class. That's really cool. Okay, sorry I took so long. I subscribed to 3 more channels because once I put in combo class, a few more things came up and I was like, ooh, these will be good to subscribe to. Alright, lists can hold reference to any or multiple data types, including other lists. Oh, reference to any. Wait a second, but lists have to have the same type. Like it has the data that's in the list has to be of the same type, I would assume. But it says multiple data types. They don't have to be the same. Like, they're in my list, there could be like an integer and a string is like the second item in the list. And oh my god. Okay. Loosey goosey. Except when it comes to the spacing, then it's not so loosey goosey. Then it's like, do as I say.
N_sweep says you can put more lists inside of lists.
Lists inside of lists, exception, dictionaries, functions, classes, functions, and any mixture of these different things. Okay. That's pretty crazy. Other list. Like any sequence, items can be accessed via zero-base index number.
N_sweep says I guess I should say objects rather than classes.
Oh, okay.
N_sweep says not the object itself.
Lists can be copied in whole or in part via slice notation or list.copy. Interesting. Lists support both common and immutable sequence operations such as min, max. Am I trying to... Maybe we'll click on them. I wonder what the difference between common... Oh wait, these are common. I'm gonna say common and mutable. What in the... Mutable sequence types. As an instance of mutable sequence type.
N_sweep says mutable sequence types are all the things you can do to a list that will change it.
Read the list without changing it. You know what, N_sweep? They should hire you to rewrite the entire Python documentation and, like, you know, pay you really, 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 really good money, because...
N_sweep says LUL I would never.
Oh, you would refuse? You should. You're so much better than this. I get, like, 1% information when I try to read this. Like, that's how much I understand. I hate. This is the
N
worst.
underscore sweep says someone can ask me questions and then write it themselves.
Aha. Okay. So as long as I learn enough Python, then I'll have to rewrite the whole documentation, or make an LLM that's only purpose is to rewrite. This is all of this, so that it doesn't suck. List.index. Index, list.index, list.append, list.reverse. List elements can be... Oh wait, let me guess if these ones are like mutable or not. Because you said it's if they change it. So this one seems like it changes it. This seems mutable. And this one seems mutable. Dot index. What does index do? I'm gonna guess common, because I feel like this would give an index of something, but it looks like these other ones kind of the syntax. Oh, it is. Okay, cool.
N
So
underscore
common.
sweep says index returns the location of a specified item.
Awesome. And then I have a feeling these are also common. Like it's gonna return the something like the minimum and the lowest one on the list, or the highest one on the list, or something. Under the hood, lists are implemented as dynamic arrays, similar to Java's array list type. Ah, thank you. See, that's why
N
you're
underscore
1,000
sweep
times
says
better
100%.
than the documentation. You just give me like one sentence and suddenly it makes sense. Under the hood, lists are implemented as dynamic arrays, similar to... Oh yeah, I read that. And are most often used to store groups of similar data, strings, numbers, sets, etc., of unknown length.
N underscore sweep says the other thing I have over the docs is I can say yes to a clarifying question LUL.
Well, if the docs could talk, instead of saying yes, they would give some like really long obfuscated answer that ends up like translating to yes, but I wouldn't understand that it's actually saying yes. I'd be like, well, is that yes? That's how bad the documentation is. Like, as long as it keeps that
N
style.
underscore sweep says LOL, yeah,
I
you're
know.
right.
It would say something like, well, you could say there is a high degree of probability that the answer might be, in most cases, perhaps the one
N
that you would
underscore
most
sweep
expect.
says LUL,
It's like,
LUL,
what?
LUL.
That's what it would. That's what it would talk like. Under the... Oh yeah, no, I'm not gonna read that again. Lists are an extremely flexible and useful data structure, and many built-in methods and operations in Python produce lists as their output. I don't know. Python seems very, like, list-lovey. Like, it seems like there's, like, lists everywhere. So whenever Python shows up, like, I'm always hearing, like, about lists everywhere. Construction. A list can be declared as a literal with square brackets and commas between elements. So wait, lists can be non-literal too?
N underscore sweep says a list for you and a list for you.
Yeah, lists for everyone. Python isn't object-oriented, it's list-oriented. No elements equals no list. No elements. One element, guava. Elements separated with commas.
N underscore sweep says non-literal is calling something that returns a list rather than constructing the list with yourself.
Oh, wait. Calling something that returns a list. So it just means it's empty? That's about it? Because you're not writing things in it? Oh, it would still be literal. Calling
N
something.
underscore sweep says even if you put stuff inside it would be a literal definition.
Oh, I see. Like another function might make a list or something. Oh, but you're not literally doing that thing. It's like the function itself is doing it for you. Okay. Thank you. Readability. Line breaks
N
can be
underscore
used.
sweep says exactly.
Cool. When there are many elements or nested data structures within a list. Many elements. Okay, at least you use line breaks here. Nested data structures. You can nest things inside of the list. Oh my god. Sunflower, poppy, pansy, tulip, fuchsia, cyclamen. Have you ever even heard of this? Of a cyclamen before? Oh, wait a minute. Oh no.
N underscore sweep says just you wait for JSONLUL.
Isn't JSON one of the things, one of the file types or something you use for storing data? That's something that, like, you know, most people have to work with at some point if you do programming stuff. Well, we're gonna find out what a cyclamen is right this second because I want to know because it's important. It's either a flower or color.
N underscore sweep says it's a file type, yes, pronounced
Oh.
JSON.
Jason. Look, it's a cyclamen. I don't think I've ever seen these. They look like fake. They look like fake plastic flowers, don't they? Just the way they're shaped. They're weird.
N underscore
Oh,
sweep says maybe more like JSON.
JSON. JSON.
N underscore sweep says JSON.
Okay, close the. Maybe like J. Sun? Where is my Python? Python. I need to change the order of tabs. Lavender. Lots of entries. Each data structure is on its own line to help clarify what they are. Nested data structure. Oh my god. Okay. Fish, gold, monkey. What the?
N underscore sweep says here you have a list with a dict, a tuple, and another list inside.
That's cursed. A list with a dick, a tuple, and another list. Okay, so. Okay. I just gotta accept it. Don't fight it. Don't fight the cursedness of what this is.
N underscore sweep says there are 3 items in your exterior list.
Oh, they're grouped. So this is 1 item, 2 item, 3 item. Oops. Okay. So I think. Wait,
N
let me try to find.
sweep says exactly yes.
Okay, I want to try to identify each one. One is a list, one is a tuple, one is a dictionary. So this is a list in a list. So which one is a tuple and which one is a dictionary? I guess this is a dictionary? Wait, no, I don't know. How can you tell one's a tuple? Oh, whatever, I'm just gonna do it. I have a 50% chance of guessing right anyway. I think this one's a tuple, and this one's...
N underscore sweep says the thing to remember about dictionaries is they have key, value
Key
pairs.
value. Oh. And you know this one is a tuple because of the parentheses? Aren't there supposed to be like... Oh.
N_sweep says yes.
That's weird. Tuples in C#, if I remember right, they stored like... It's like they stored multiple variables for one value in like lists or something. It was like that.
N_sweep says dicts and sets both use curly braces. You can tell them apart by whether they use the...
Both use curly braces. Oh no. That's cursed. Whether they use the thing. Oh my god. Individual values.
N_sweep says sets just have individual values like lists and tuples.
What? How are those? That's weird. These seem different then. Well, I haven't reached the part where it talks about tuples in Python yet, but in C# they seem like very different. Like they look like, let me look at it again. But I feel like if they're using the same word, they have to be related in some way. At least in the sense of like immutable list.
N_sweep says a Python tuple is essentially just an immutable list.
Wow. What do you think about like these tuples? I want to say tuple, but Wynn looked it up last time, and then the dictionary said it was tuple apparently, and I was like, oh. Oh wait.
N_sweep says I don't know which is right lul.
It's just the dictionary, yeah. But yeah. But tuples in C# just hold 2 or more fields. Like this one. Holds a bool and a string. Oh wait, I guess it is kind of similar. In a sense, like it's like a single list kind of something. Huh. I see. It's just weird without like the types there.
N_sweep says tuples in Python are capable of holding one item.
Oh. I don't even know if you could do that in C# or not. Huh.
N_sweep says there isn't
oh yeah,
much use,
like why do that when you can just do...
Since you can just hold a single value in a variable lol.
Hey, but it's good to know. I like knowing when things are just possible to do, even when they're like highly inefficient or whatever, just to understand like what is allowed. Especially in a language with 300,000 layers of abstraction, so it's like very confusing to figure out how all the pieces are related to each other. And then the documentation. You know what? It makes sense. The documentation is also 300,000 layers of abstracted English, too. That's probably why it's so messed up.
N_sweep says there are also bugs that can come from accidentally creating a tuple lul.
Oh, that sucks. Oh, Python's not perfect?
N_sweep says you'll hit one of those someday. The problem will be an unintentional trailing comma.
And when it happens, I'll remember you. I'll be like, N_sweep told me. He told me it would happen. It finally happened. Oh no. I dread that day. This language makes me shake my head.
N_sweep says nah, you'll kill it because you know the future now lul.
But I won't be able to prevent my fate. And I'm guessing, like, the bug doesn't go away when you just, like, try to rerun the program and hope it's like, okay, hope it'll just run this time when I click on the run button. Nested data structure, fish. Oh, it's running fish, monkey. Ray. Huh. Wait, let me read the thing that you wrote, that other comment again.
N_sweep says ha ha ha, I'll admit I have seen bugs like that too.
Oh. I don't know, this this Python, the more I learn about Python, the more concerned I feel about it. Like, is this language doing alright? What was that? The list constructor can be used empty or with an iterable as an argument. Elements in the iterable are cycled through by the constructor and added to the list in order. Oh, there's a constructor for lists too. Okay. In the iterable or cycle through the constructor, add to list in order. Okay. The table is unpacked.
N_sweep says I get it. Coming from C.
I would say not necessarily, but if I had an opportunity that was available in Python, I would take it. Any language. Any language. I'm interested in computers and computer science in general. And I like all the stuff. Except the esoterics. Except the esoteric languages. It's a little too much for me. But yeah. I would say I'm more, if I have to pick, I'm more interested in like C, C++, and C#. Like lower level things because I'm interested in game development. But Python's really cool, especially because of all the things right now. With the magical word AI, and that's where the stonk is too, so it's pretty cool.
N_sweep says cool.
But it's cursed. It's cursed. It's cursed. It's cursed. Yeah, maybe not the best choice for imagine Unreal Engine Python edition. A disaster. It'd be horrible. The Unreal stonk would drop to 0.
N_sweep says oh no.
Then wouldn't you be excited? Wouldn't you want to make games in the Python edition? But the whole backend encode it, code it in Python too. You try. Yeah, it'd be worth it, at least for the memes.
N_sweep says I would totally try it, haha.
You get like a stellar 5 frames per second.
N_sweep says I'd make a snake game in UE for sure, lul.
Heck yeah. Hey, and that's appropriate for Python too.
N_sweep says or Conway's Game of Life.
Oh, nice. But you need the like high HD texture still. I mean, it's Unreal Engine, so we gotta take advantage. Gotta take advantage of that. Tuples impact and each element is added. Multiple elements from tuple. List, parrot, bird.
N_sweep says it would be a really realistic snake.
I'm kind of wondering, like, what's the